carbon footprints of two Spanish fishing fleets, and with some impact on greenhouse gas emissions, carbon efficiency, with Melissa Bailey. Melissa Bailey. We're going to talk about carbon storage on the beautiful Mediterranean coastline Oceanica. We love this south of France. With some blue carbon aspects, I guess, spoilers, and Melissa Calvino. We're going to compare the degradation and ecotoxicological impacts of different types of plastic industry. As usual, you know the drill, 15 minutes presentation. I will show you maybe two fingers for 2 minutes or one for 1 minute if you need, but I guess it's better if you have your timer with you. But you're professionals now, good. And then 15 minutes questions with the jury. So I just one word on you. So the jury composed by
Florence Marie de François University. Eduardo Marque from the University of Oviedo in Spain. Ana Maria Rafiado from Ghent University.
Heidi Tempora from ATU.
Sorry, second year from Université Côte-d'Azur. Good luck and enjoy this moment.
Thank you.
The floor is yours.
Okay. Hi everyone. As you said, my name is Ella, and today I will be presenting my master thesis, comparing carbon footprints of Spanish Purseine and Canarian Poland line tuna fleets, sharing insights from 2 decades of vessel monitoring system or VMS data. Starting off with a little bit of background, fisheries play a critical role in food security, employment, and livelihood for many coastal regions globally. Historically, sustainability discussions in fisheries have focused primarily on biological aspects like overfishing, stock depletion, or bycatch, but recent growing concerns with the contribution of food production system to greenhouse gas emissions have brought further attention to the contribution of capture fisheries to climate change and increasing carbon emissions. So as I said, fisheries represent a very small percent of total food system emissions, about 4%, but their intensity can be quite high when represented per kilogram of seafood. And throughout the whole fishing chain, fuel burning at sea for vessel movement and gear deployment has been consistently identified as the major contributor to greenhouse gas emissions. So that's why I will be focusing on that. By comparing different fleets, we are able to identify the specific drivers impacting the carbon performance and hopefully help guide more climate-oriented mitigation strategies and identify opportunities. Tuna fisheries are one of the world's most valuable fisheries, globally traded, with about 8 million tons caught in 2022, with the first sale value estimated at over $40 billion. Tuna can be caught in various different strategies. I will be focusing on 2. The first one being the Purseine. As you can see on the image, essentially just a large net encircling the school of tuna, and as it's being dragged to the vessel, there's weights at the bottom pursing the net. The other method is more smaller scale, using a traditional pole and line, catching the tuna one by hand. Within Spain, these 2 methods exist, and they host one of the largest and most influential tuna fleets in Europe and globally. For the Purseine, the Spanish tuna fleet is about 2/3 of the whole EU capacity, so they are really important for the tuna fisheries. And in the Canarian Islands, the pole and line fleet is disproportionately contributing to the local economy for over 2 centuries. So once again, very important. And these 2 fleets operating in the Atlantic Ocean give us a really rare opportunity to look at 2 fleets operating in very different fishing strategies, but targeting the same fish, operating under the same national context and the same regulations. So it's giving us a really rare opportunity to have a look at what drives their performance. Therefore, my study looked at contrasting the carbon performance of these two fleets, specifically quantifying and contrasting the scale and the spatial distribution of CO2 emissions, as well as examining the temporal trends across 2 decades and the variability in carbon intensity, which is amount of carbon per ton of tuna landed, as well as investigating the specific drivers behind this intensity to answer the general question of do contrasting fishing strategies translate into differences in carbon performance and how? And to do so, I've used a bottom-up power-based emissions model incorporating 20 years of vessel monitoring system data and official landings record. So the vessel monitoring system data was provided by the Spanish Ministry of Agriculture, Fisheries and Food. All vessels over 15 meters in Spain it's mandatory to have these systems, which included 33 purseaners, which is the whole fleet operating in the Atlantic, and 35 Poland line vessels, which are 64% of the fleet in number, but 88% in installed power engine, because some of the vessels are smaller than 15 meters. And as I said, we have 2 decades of data from 2005 to 2025. As well, we also have the vessel characteristics like the length and the power engine, which come from the official fleet registry. So the vessel monitoring system is a system that sends a ping to satellites every 1 to 2 hours with the specific location, specific time, the speed, and the angle of the vessel. And we can use those characteristics with the power engine to incorporate in a bottom-up model. I won't go too deep, it's a bit scary. No, but basically, for each VMS interval between 2 pings, I calculated the total emission by using the power engine of the vessel, an emission factor for CO2, the duration of the interval, and then a load factor calculated from the difference in speeds. After that, we incorporated the daily landings from the IAO Tropical Tuna Research Group, which included 5 species of tuna, 3 tropical ones, which are skipjack, yellowfin, and big eye, and 2 non-tropical species, which were albacore and bluefin tuna. So what did we find out? I'm sure you're dying to know. For the general characteristics of the fleet, as you can see, the Persane in blue and the Poland line in orange. For the Poland line fleet, the active vessels were around 31 per year, compared to the Persane were only 11 vessels active in a year in the Atlantic Ocean. Whereas the engine power and length, the Persaners were much bigger, with about a magnitude higher in engine power and almost 3-fold in length. This is what we see when we look at the total emissions. So as you can see, the Persaners, again in blue, dominate total emissions, with increase in the first 5 years of our time series, followed by a decrease, especially in the last, whereas the Poland line is much lower and a bit more consistent. It is a bit harder to see because of the scale, but it is more consistent. It's important to note, though, that this is for the total fleet, and as I mentioned, the number of active vessels can change over time. And as you can see for the Persaners, there was a decline. So to look at the per vessel emissions is also useful. Try this. So you can see that the trends are much less pronounced when you look at it per vessel, indicating that the decline in emissions or increase is probably due to the reduced capacity of the fleet in this ocean, and not so much to the actual fuel being burned and emitted. In terms of the spatial scale, the Persaners across 4 time periods dominated a very wide tropical band, with the fishing hotspots in yellow being quite similar across the time periods, just different intensities along the West African coast, followed by how many vessels were active and how many emissions were emitted, but the fishing throughout don't change that much. Whereas for the Poland line fleet, it's obviously more localized, concentrated around the Canarian Islands, with some operational behavior in Azores and Madeira in the north of Spain, but is not consistent throughout the time series. So for the carbon intensity, once we look at it per ton landed, we were expecting a couple things. One, because we have 2 decades of data and the fleet has advanced technologically since 2005 with a better fish aggregating device systems, with better sonar technology. We expected to see efficiency over time, meaning less carbon being emitted for a ton of fish as we go, but that was not what we actually saw. And you can see that there is some fluctuations yearly, but the trend, especially for the percenter, is quite steady, which once again was very different to what I expected to find. On top of that, the literature consistently reports that percenters are one of the more efficient fishing strategies, a lot of the times way more than pole line fishery, because they target these big schools of tuna and they catch so much of it. So even if they emit a lot, when you standardize it per ton of fish caught, it's actually always reported as one of the most efficient strategies. So we were expecting it to be more efficient than the pole line, but once again, that was not what we found out, and it's actually quite comparable. And you can see that the differences between the 2 fleets are smaller than the variability within the fleet. So why do we see these patterns? First of all, the within fleet variability that I just mentioned suggests that operational behavior, such as teaming behavior, decisions by the captain, specific individual fishing strategies per vessel, have a really big importance into the performance. And some vessels within the same fleet can have very different carbon performance despite being very similar characteristics and targeting similar species in the same location. This can also be seen when we look at the vessel length compared to the intensity. For the percenters, you can see that there is no trend, and it doesn't really matter how big the vessel is. It's more, even for same size vessels, you have very different performances, like I just said. For the pole line, there is some weak relationship. As the vessels are bigger, the performance is a bit less efficient and they emit more carbon per ton landed. But it's not a very strong relationship, and it can be explained because the vessels are a bit smaller. Once they are a bit bigger, they can go out farther, emitting more carbon while they burn fuel. Another explanatory variable to why we see these results are if we look at it seasonally. So on the top we have the monthly carbon intensity by fleet, and we have the landings reported for each fleet at the bottom. If you see in the percent, when the landings are lower, the intensity is higher, and when the intensity is higher, when the landings are higher, the intensity is lower, which makes sense because intensity, as I said, was kilogram of carbon by ton landed. So if we have more tuna caught, the intensity will be lower. So you can see that it's really mirroring each other. Whereas for the pole line, we don't see the same trend. When the landings are really low, the intensity is really different, depends on what time of year it is. And this can be further explained when we look at the species composition. So this is just for the pole line now. And you can see that in the time period where the intensity is really high, it's correlating with the time period where albacore and bluefin tuna are targeted and are in higher proportion. These species, as I mentioned, are non-tropical. They don't form big aggregating schools as the tropical species do. So it's a bit harder to catch them, and you need more time to search for them, meaning more time at sea, more fuel burned, more emissions per ton of tuna landed. Whereas, as I mentioned earlier, we expected the percenters to be more efficient. And we can actually see that in time periods where they are targeting similar species, because the percenters only target the tropical. In time periods where the pole line also only target the tropical species, they are actually more efficient. than the purseine. So it's contrary to what we originally thought would be. Even when the landings for the purseine is much higher than landings for the pollen line. Some management implications from my study. Focus mitigation inside fleets, not just redistributing efforts between them. The variability within fleets suggests that there is a lot of room for improvement within each fleet, and probably should focus there. Technology alone won't deliver reductions, as I've mentioned, and should be incorporated with other management strategies. And we should try to align the fishing effort with ecological opportunity, especially for the polar line fleet where they are targeting the non-tropical species. Finally, some conclusions from our study. Scale does not equal intensity just because the pursainers are bigger or because the polar line fleet has a bigger capacity doesn't necessarily mean that their performance will be correlated. Carbon performance is context dependent, depending on the season, what you're targeting, and the vessel itself. And mitigation, as I said, should target drivers, not stereotypes. And yeah, my final conclusion, carbon management in fisheries should move beyond simple gear classifications.
Ella for the presentation and also for time management, perfect. Can we start with you, Laurence?
Yes.
Then on to the right and we'll do the presentation.
Thank you, and really, congratulations. It was very clear. So, in terms of management, because okay, we have seen, I agree totally with your analysis of your results. But what's next in terms of management? How would you try to improve the emission or to reduce the emission using management? Do you think you could go for a better localization of or better classification of fish stocks before you go fishing, or is it maybe a better education on how to drive the vessels in a more economic ways? What would you target?
I think it's probably a combination of everything, specifically because there is such wide differences within the fleet with vessels that are basically the same. I think it's really important to explore why these differences are. Maybe it's something as simple as they use different paint on the hulls and there's less resistance, so they use less fuel. Maybe their use of the technology surrounding the fish aggregating devices is better. I think for, like, if I say about the FADs, the fish aggregating device, for as of now, I think maybe they are limited by numbers, but it's not looking at, okay, what's the yield for each FAD or where they are spatially located, and maybe if you know those information, you can better characterize, okay, it's not just numbers, but it's also like which is better performing. So I think looking at the operational behavior is important. I also think for the industrial fleet, there are subsidies a lot more than the pollen line because they catch so much, and it is important for food security. So I think maybe incentivizing the vessels that are better performing in terms of fuel subsidies could be one way to approach it. And I think for the polar line fleet, yeah, improving knowledge on the local availability of where the tuna is, especially for the non-tropical species, I think could really help reduce the emissions, because if you know where they are usually, it's way faster to just go there and target them. As we saw, they are, I think it's hard to see in this because I don't show the bigger context, but these two methods are some of the most efficient in fisheries compared to, say, trawling or even long line. And it's also important to remember there's socioeconomic aspects outside of carbon emissions. I do think it's important to look at it, but the pursainers will also usually have more bycatch, will target more juvenile species. If you look at the value chain, usually they export it more, and it's for canned tuna compared to the local polar line, which are more sold to fresh fish market, contributing more to local economy, providing more jobs. So I think it's I think it's obviously my focus on emissions, and it's I think important, especially climate change. Sorry. But I think it's important to keep it in like a bigger context of, especially now with the.
Sorry,
Sorry.
maybe to try to keep your
Okay.
answers
Sorry.
within 1 minute so we can also have more minutes
Okay.
on the phone.
I hope I answered.
Sorry.
Okay.
So, with a short answer.
A
Sorry.
very short one, so that
Yes.
we are fine with that.
Yeah.
Do you think there are many boats that are shorter than 35 meters?
Then 35 or 15?
You lower the threshold for the boats.
Yeah, so
Uh,
15
yes.
meters is
Yes.
mandatory, above 15 meters to have VMS. So we have data for all the
Okay.
boats above 15. For the Persane, all the boats are
Yes,
very big.
certainly.
For the Poland line, it's 64% of the fleet by numbers are over 15, but it's 88% of the installed power.
Okay.
Yeah.
Okay, thanks.
Thank you. So, my questions, first, congratulations, because I really enjoyed your presentation. The slides are very clear and very good. And also topic is important and timely today. When I think we should abandon destructive fisheries, but this is my own opinion. I have just two questions. I'm not, let's see, what do you think? I think it's more your opinions than based on your data that you have solved it very well, the methodology explain it, so everything is for me, is good in this presentation. And the first question is in the map you have presented with
Yes.
the spatial scale where the fleet went in different,
Yes.
in the different periods you have considered. I see that in the pole line there are changes in the movements of the fleet and in the space where they go fishing, and especially the last 5 years, it's like wow, they have expanded a lot the
So-
area. Why do you think this change in the spatial scale is happening?
So I think the boats that go further are obviously the bigger boats. And when you see the going to the north of Spain here, and it also happens like here, it's just obviously averaged across 5 years to be able to show you the gen because it's a lot of data.
But they have
But
like
these-
more in the middle also. I mean, it's like
Yeah,
more
these are
expanded.
because they are going there, and my emission calculation captured all time at sea, not just the fishing itself.
Mhm.
So even the going there, you're burning fuel. But these are usually 2 vessels a year.
Ah,
Yes,
so it's more
it's
relatively.
it's
more
because
stable.
there's good opportunities to catch albacore in the north of Spain. So it's worth it to them to send 2 vessels usually a year to go up there. They stay there for a while for the season, and then they come back. And as I mentioned, it's the bigger boats, but it's not as representative of the whole fleet.
Ah, okay. I see. Because with this gear they catch more species.
They still target tuna.
Different.
It's still tuna.
Yes,
it's
tuna,
just
but
different
species.
species. Yes.
Okay. So they may change the targets.
So the Persainers only target the 3 tropical species: skipjack,
Yes.
yellow fin, and big eye. And they target as well bluefin, which is very economically lucrative, and albacore.
So the second question is, would you put these results in the context of global change? Perhaps
So-
the species are moving, or
Potentially.
what
And
do
I
you
think that's what I was talking when I trying to say to align the fishing effort with ecological opportunities.
Mhm.
I think it's a bit out of the scope of my specific study, but if you investigate better models of distribution of these non-tropical species in abundance, I think it can help make it more efficient to fish them.
It's okay because you almost answered my question because my question was actually going to be like because you mentioned to align fishing efforts with the ecology of the fish, and I was gonna ask like what are your thoughts about that? What would you suggest from your experience?
Yeah, so I think literally just as I said, especially for I think for the Persane, it's happening really well already. They have really good technology to detect the schools. The use of the fads is really well done. I think it's more for the pollen line, which also some might not have the capacity as the big industrial fleets to have these technologies. So I think, more knowledge on the local availability of tuna, where they are, when they are there, and how much is there, can help align the effort to where they are more. And instead of spending so much fuel trying to find them, you go there, you get them, you come back, it's more, you burn less fuel, you emit less emissions.
Also, I mean, I'm not sure if I understood correctly, but maybe it's like, is it also like time related? I mean, in terms of like time of the year and seasonality, that depends on the fish, I guess, or the
Yes.
species that you're
So-
targeting. Is this already happening or no? From you saw a graph with the months and the different species somewhere. It was really interesting.
Sorry.
But yeah,
This
maybe
one.
you can, yeah.
Yeah, so this obviously looks at the actual landings data. So it's not I can't say for sure about the abundance or the distribution, but I can assume that if they are catching more albacore and bluefin here, it's because the opportunities are available
Yeah.
and make sense.
But my
And they are
question
more
is
on
more
the
like they're
area.
looking for these all species throughout the year, no? Or
I
no?
just think
I'm
they are not as present in the later months of the year just because of their ecology and where they are being. Compared to the tropical tuna that are quite consistently in the tropics area.
Would it be like an idea that they're targeting their fishing efforts to the months or periods of the year that are more abundances are higher for certain species or so on, right?
I think
Rather
it is
than-
already happening because also for them being a bit
So,
smaller
but-
scale, like you need to make sure that what you're catching is worth the money you're spending on fuel and all the capacity. So I think I trust the fishers to know when it's cost effective for them to go. I think we can help by helping them even more to make it more cost efficient, especially for the smaller coastal fleet.
But there is no restriction.
Not that I'm aware of. I think it's because they are not there.
Correct. Thank you.
And I just have one quick one. I'm just looking through the phone ones I had. But yeah, have you looked at similar data, I suppose, or similar results from papers for other commercial species
Yes.
in comparison?
So I have here for other tunas that are also Persane and pollen line. And I've read from the literature about other species as well. As
How
I
do they
said,
compare?
they are doing really well. Like they are very efficient. Especially the tropical species because they form really big schools. And especially with the fads nowadays, you have a sonar, you know how many tons of fish are in the fad, you just go, you catch them. So they are really efficient in terms of carbon emissions. the pollen line, like I said in the middle of the literature, is usually worse, less, better, I don't know how to say, like more intense. But because they are, look, a lot of the published studies are from pollen line fisheries that target albacore. So, as I mentioned, it takes more time to search.
Yeah, no, I meant other commercial species, not necessarily tuna species.
Yeah. I think tunas are, I don't have specific numbers now to show, but they are doing pretty on the like more efficient scale than other, like sardines or.
Okay, yeah, that's what I wanted to know.
Yes.
Perfect. Okay, thanks very much.
Sorry.
I saw also that we have
Is it this? No, this is the other Melissa. Where are you today?
and we're going from the Atlantic to the Mediterranean Sea. In what possible. Good for you, Melissa. Just 2 seconds, everyone find the seats. The floor is yours.
Hello everyone, my name is Melissa Bailey and today I'm going to be presenting my thesis research on modelling and quantifying carbon storage in Posidonia oceanica seagrass meadows along the Baix and Porta coast in the northwest Mediterranean. I undertook this research at the Blani Centre for Advanced Studies with the Aquatic Macrophyte Ecology Group with the Spanish National Research Council. My supervisors were Dr. Oscar Serrano, Nicole Foster, and Dr. Edward Serrano. So the global ocean acts as a massive carbon sink. Essentially, 25% of global human anthropogenic carbon emissions have been sunk between 1960s and 2010. We've got blue carbon ecosystems, which are comprised of mangroves, seagrass meadows, and salt marshes. And these only occupy 0.2% of the sea floor, but they store 50% of marine carbon sediments in their ecosystems. Seagrasses store 10% of marine sediment carbons, and Posidonia oceanica is the seagrass meadow which is endemic to the Mediterranean, which has the biggest blue carbon potential. They have these thick mat structures that have thick rhizome and roots that help accumulate carbon in the sediments and store them for long periods of time for hundreds to thousands of years. However, on the flip side of these ecosystems, if they are disturbed, there is the risk of potential remineralization of the carbon that has been stored, which could be re-emitted into the atmosphere. Therefore, in general, in blue carbon ecosystems, and especially in Posidonia oceanica, because of how much carbon they store, there is growing interest in the restoration and conservation of these ecosystems and carbon accounting to know how much carbon is actually stored to be potentially incorporated into carbon credit frameworks. However, there are some big unknowns with these ecosystems and for modelling and quantifying the distribution of organic carbon and calcium carbonate stocks. So this study is the first of its kind in the Mediterranean, spatially explicitly modelling and quantifying these two carbon stocks in a very site-specific manner. So that takes us to our main research question, which was how do environmental variables influence organic carbon and calcium carbonate storage in Posidonia oceanica meadows? So there were 3 aims in this study. The first one was to build an environmental dataset of sediment and environmental observation variables. And then from these variables, we want to identify the key drivers distributing the carbon. And from those drivers, we're going to create a model that can quantify the carbon stock. Our hypothesis was that sediment type, slope, exposure, freshwater inputs, depth, and human modification, being agriculture and built infrastructure, will be the main influences of carbon storage, and this is influenced by the literature that exists around seagrass meadows and organic carbon. So our study area was 30 kilometres of the Baixo Import of the coast, where we had 9 different seagrass meadows, where we collected 2 to 5 sediment cores per site. In total, we had 34 sediment cores along a depth profile of 8 to 20 metres depth. And in total across this area, we had 99 hectares of seagrass meadow. Once we had taken the cores, we took them back to the laboratory and analysed them for organic carbon content through loss of ignition, calcium carbonate content through a carbon dioxide degassing technique, grain size using laser diffraction and a mastizer 2000, and dry bulk density. We then used dry bulk density with the organic carbon and calcium carbonate contents to get our response variables of organic carbon and calcium carbonate measured in megagrams per hectare for each respective response variable. From there, we extracted Earth observation data primarily from the Copernicus Marine Service products along the hydrodynamic, climatic, biogeochemical, terrestrial and anthropogenic factors that have been shown in literature to have an influence on these carbon stocks. And for each of these variables, we extracted them from the grids that existed online to the core sediment locations so that we had full data sets for each of these locations to then train our models later on. So in total we had 38 predictors initially, which we then whittled down to 32 predictors using correlation matrix and ecological interpretability. And from there we plugged these into boosted regression tree models to find the best predictive performance, to be able to apply this to spatial maps using raster layers, to then pull this through to predict carbon stocks across Posidonia oceanica meadows. From there, we took total stock quantifications and converted this into CO2 balance, and then we were able to say that this is the baseline conservation and restoration carbon accounting carbon stock, which I'm going to go into more detail on. So, boosted regression trees are ensemble machine learning models that use regression trees and boosting, and they're great for helping to explain complex relationships between a response variable and multiple predictors. So essentially, we started with all of the predictors here in our initial boosted regression tree models, and then we tried to get the best explanation. So the cross-validated deviance explained to the highest percentage possible using the predictors that we had from our data set. So the CV deviance explained is essentially how much the boosted regression tree improves the prediction compared to a null model, which just looks at the mean across the board for organic carbon and calcium carbonate. So for organic carbon, model performance was 35%, which is comparable to other blue carbon studies in the space, which looks low, but it's because there's more complex biological and depositional controls at play. But we had 6 predictors, which you can see here on the left, that came through as the main predictors for this model. For calcium carbonate, this model performance was 60%, which indicates that there's stronger environmental control from the predictors that we had available in our data set to explain the variation of carbon for this pool. So within each of the models, first of all, this is a partial dependence plot. So on the y-axis, we've got the fitted response of the response variable, organic carbon in this case, and then along each of the x-axes, we've got the predictors. So you can see here in the brackets how much of each of these predictors influence the response variable within the model. So fine grain size below 0.06 millimeters explain 28.8% of the relative influence within the model. So it's dominating the organic carbon storage, showing a negative relationship when the quantities of this grain size are low, but above 5%, it increasing the quantity of organic carbon as it increases, and then it plateaus at a certain level. The opposite trend is observed for coarse grain size above 1 millimeter, but this still explains 23.7%. So from this internal relative influence, we can say that the fine grain size has the greatest influence on this model. and this is due to the correlation that we see in other studies as well that looks at with fine grain size there's less oxygen penetration and less potential for carbon to be remineralized. Okay, so from these 6 predictors that we just saw, we created raster layers that we stacked and then overlaid the seagrass shapefile as a mask and put the trained boosted regression tree model into those raster layers. So essentially this trained each of our cells, which were down to 15 meter squared resolution, and with sediment variables we had to interpolate a raster, and from the Earth observation data those grids already existed, so we just had to draw in those values into those grids. And for every cell, the boosted regression tree used the different variables that were at play and the weighting that they had on the potential distribution of the carbon, and they pulled through a quantity of carbon. So you can see that dark blue is 12 megagrams of organic carbon per hectare, and then the yellow goes up to 38 megagrams of carbon per hectare. So Saituna was our most northern site and had the greatest carbon quantity in general, and Tamaru was our middle site, and Playa Grande was our most southern site out of the 9. And the trend is the most northern sites has the greatest carbon content, and the southernmost sites have the least. You can see that there's an embayment around Saituna, so this means that there's this hydrodynamic activity which is associated with, so less hydrodynamic activity is associated with fine grain size. So although the Earth observation data for high hydrodynamic activity or hydrodynamic activity wasn't pulled through, sediment grain size can also be, say, not a proxy, but part of the explanation for that particular variable. And then, Playa Grande has a very low sediment carbon stock as it's by human settlement, and it's a bit more exposed as well. So although in our model hydrodynamics didn't come through, we think that it's still got a very big part to play, and it's very closely associated with grain sizes that we find, and this is again supported by the literature. So internally within the carbon stock, the calcium carbonate model, grain size was found to have the greatest influence, again with coarse grain size above 1 millimeter being highly associated with a large amount of calcium carbonate when the content of coarse grain size is great. And we've also got another 8 predictors that explain part of this model. So coarse grain size is associated with shell fragments and other biogenic material, which is associated with calcium carbonate, which is again supported by literature. And we took these raster layers and expressed them again with the trained regression tree model. And we saw a similar pattern of distribution as with organic carbon, despite having different drivers influencing them. So again, Playa Grande being the most southern site and Saituna being the most northern site. Saituna, as it's the most sheltered, has the highest accumulation of both carbon and calcium carbonate content, despite the different drivers coming in, so storing the most below that meadow. Okay, so now that we have our quantification from the models by looking at the rasters and the trained models, we then can look at the full carbon stocks. So in general, in the Baixan Porta, we had a per hectare quantity of 20 megagrams of organic carbon, compared to the Mediterranean mean, which is around 110 megagrams of organic carbon. So this is 5 times lower than the average mean. In general, the Baixan Porta is a hydrodynamic area and a rocky substrate, so it's not accumulating as much sediment in general, so it has lower carbon stocks. The calcium carbonate quantity is 10 times larger than that of the organic carbon, but there's less studies available to be able to compare that in the Mediterranean. So in order to get the carbon dioxide equivalent of how much carbon these ecosystems are actually storing in the seagrass, we can use some conversion factors to get the carbon dioxide equivalent around timesing carbon by 3.6 approximately, and to be able to convert calcium carbonate into carbon dioxide, we first have to convert it into its carbon equivalent, and then it also releases carbon dioxide in its biogenic production. So for every mole of calcium carbonate produced, it also produces 0.63 moles of carbon dioxide. So that's why we need to consider both organic carbon and calcium carbonate in the stocks, because if it's got more calcium carbonate equivalent of carbon dioxide, then we need to be able to determine if this seagrass meadow is actually a net carbon dioxide sink or source. So overall, this meadow actually acts as a carbon dioxide sink, and we also considered biomass above ground and below ground, which again used conversion factors to look at the total stock. Its carbon is also stored in the living plant with the leaves and the rhizomes, and this was around 40 megagrams of carbon dioxide per hectare. So limitations were that we had to extrapolate 9 of our cores to 30 centimetres of depth, and that our earth resolution was pretty coarse, so it wasn't able to be pulled through in the models as well as we would have liked. And our key findings are that sedimentology dominates carbon storage models, spatial modelling provides these baseline inventories, and that our meadows in the Baixan Cordillera do function as a net CO2 sink. Thank you.
Congratulations, you made it on time. We can start with Katie and come back this way.
Melissa, thank you very much. I thought your presentation was excellent, and the amount of work that you've done is also very commendable. So well done. I have a few more general questions. So, so what do we do now with your results? Would you recommend extrapolating this to other meadows? Do you think that this is an efficient way of looking at carbon sink?
Yeah, I think it provides a baseline and it performs better than taking, say, a mean across the board. But I do think that Earth observation data needs to advance and become high quality before we really employ this technique at scale. Because obviously factors like the hydrodynamics, which have been found in other studies to be significant influences at a regional scale, are harder to pick up at the local scale because the resolution is around 4 kilometres, so it's not being pulled through in the kind of significant way that I think it should be. But I think the framework's definitely there. I think it would be a really good method to perform when that data is available, and it's better than taking the mean.
Okay, if you were to start your project again, what would you do differently?
I think maybe because of the coarse resolution of the environmental observation data, it would be nice to cover a larger range of area to be able to see those variables come through in a stronger way. But obviously this is a study looking at the site-specific areas compared to regional. But I think, it would have been interesting to see how they play at a different scale. But would have taken a few more cores because 34 is a small sample size. So it would be interesting, to take a larger sample size and see if that influences things
Are you
as well.
continuing this work or not?
I'm actually starting a PhD.
On this?
Yeah.
Okay,
So we're continuing this.
okay, thank you.
Yeah.
Okay, great. Yes, I would also like to ask about the course. Actually, what scale did you sample?
What?
In a spatial scale.
As in depth of the cores, or
As in the distance between cores.
they were at least 10 meters apart.
Yeah, and also, I mean, that's very interesting, and of course, it's a dedicated sampling would add a lot more to this, but of course, you can just inform and more your models, but this is gonna be the same outcome more or less. You can just empower more your models, but it's very interesting what you saw and also what we can learn from this and apply in other ecosystems.
Yeah.
I was also wondering because seagrass, Posidonia is also quite special. It's one of the seagrass that it's old plant, let's say. They create these rhizomes, and the rooting system is quite deep. So I was also wondering whether this can be applied for other seagrass species, or is Posidonia specialized? What do you think, or what would be the modification, let's say, to apply to other species if you have to add more factors or more adjustments in your model?
I think this method could be replicated across different seagrass species. Posidonia in general is a carbon king. It's got obviously that mat which stores a lot more carbon. But I think the method still stands for applying it to other species, taking the core, looking at the carbon content and the various different sediment variables, and then applying the Earth observation data. I don't think I'd change anything applying it to other species, but yeah.
It's one small thing that crossed my mind, because we are talking about also restoration that is now thing.
Yes.
We're also concentrating our efforts to that. But I was thinking about what about habitat fragmentation? What is a big problem in the Mediterranean and sort of the coastal areas that are also busy, and we fragment a lot of the meadows. So I was wondering whether if carbon sequestration, because this is per hectare, or I don't know how it's measured in the scale. But is it related with the size of the patch, like the density of the meadows? I mean, it's obvious that the larger the meadow, the more the carbon sequestration. That's logical. But is it also related? You know what I mean? The more you fragment it, the less the potential for carbon sequestration. Do you know about that?
I don't know specifically, but I would go as far as saying yes, because with the larger space that the seagrass meadow is existing, you've obviously got more carbon coming in stored in that mass of the ecosystem, habitat builder. In any fragmented space that, say, was once Posidonia, that's going to have been disturbed in potential large remineralization. If it's dead mat, there's still potential for it to be holding a large amount of carbon. So restoring those areas is really important. I'm not sure exactly if there's been studies done on fragmentation and the carbon storage associated, but I would assume as much as with a greater area of any carbon sequestering and storing habitat, that it would be greater, and the kind of overspill of that carbon surrounding it is greater as well. That answers your question.
Yeah, that's a great answer. Yeah, thank you very much.
Yeah, thank you.
Thank you. Thank you very much for a very nice presentation. Congratulations for it.
Thank you.
A great work.
Thank you.
Way.
It was fun.
Here you have presented a lot of data from the original data on carbon storage and sediment size, grain size, measurement, carbon measurements, a lot. So the first question is just curiosity. What part of the data are yours? I mean, did you do all the work, the field work and the modeling?
Yes.
Wow, it's impressive.
It was a lot, but it was so fun. I love diving, so I was I have to be part of that part to make the rest of it worth it.
And 2 different locations. I mean,
Yeah.
different Posidonia meadows, I guess.
Yeah, it was really good. Big shout out to Natura Vigo Project by Biosphera Environmental Education Association, who planned and executed and supported all of the field work. Yeah, so thanks for reminding me.
Excellent, very good.
Yeah.
I didn't have the opportunity to read your thesis, but I'm sure it's.
Oh,
That's why I'm asking the question. And I have only a question for you. I see that grain size dominates the carbon storage, but human modification is not apparently very important. What aspects of human modification and anthropogenic changes have you considered here?
Yes, so the global human modification is comprised of 5 different factors. So it was agricultural related modification and then various different built infrastructure, so energy, population density, and 2 different metrics around built infrastructure. To be honest, I consider it quite a strong factor influencing organic carbon. This data set was at a 1 kilometre resolution, which was one of the higher resolutions from the Earth observation data that we had access to. And yeah, so this coming through at that resolution, I think indicates that it has a pretty large influence. Obviously, I'm really excited to do this model again in a few years when our data sets are improved and to be able to see like actually how much this influences when it's at a greater resolution. So I think the fact that this is the only Earth observation data predictor that's actually come through in the model is saying something quite significant because these are all slope derived from the sediment core, and then slope was taken from very high resolution bathymetry data set. Yeah.
Okay, thank you very much.
Thank you. Oh,
Yes.
Okay. So Melissa, I'm glad that I came to your talk this morning because I would have bet that the organic carbon would be the main driver of the variance, like more than the 35% that you observed.
Yeah.
And on the contrary, it is the inorganic carbon that is like the 60%. You see, I would have just switched the values. That would have been my bet. So I see that thanks to your work, I have it in a better way.
Maybe I can clarify that point. So this is how much these predictors were able to improve
Yes.
off the mean value, and these are how this is how much these predictors can influence off the mean model. So it's not that this explains 60% or this explains 35.
Okay.
It's how much the prediction is improved by using this model.
Oh, okay.
Yeah, so it's not the percentage
Okay.
in the cause.
Okay.
Yeah, just to clarify.
Okay. Thanks.
Yeah, I was like, so, oh no, I don't want you leaving with fake news.
Okay. So now that you have explained that,
Sorry if that wasn't clear in the presentation.
no. So now can you give us like your view on the variability, on the control of the variability of the carbonate content and the organic carbon content over the meadow. And what I wanted really to ask you is if you in your study if you had a core with no coverage at all of without Posidonia, how this core would have compared to that? Like, would it have been only driven by the grain size, and here you have other variables that influence the carbon storage? What do you think? Do you see where I'm going to? I would like you to state a bit on the influence of having the seagrass meadow on the overall inorganic and organic carbon storage.
Okay, in this study, all of our cores were taken from seagrass.
Yes.
So I don't think I'm able to comment on the comparison of the seagrass cores compared to dead mat or sand. So without having that data to compare it to, I'm not feeling confident to
Yes,
comment
okay.
on those.
Okay. And for the inorganic carbon, what is the process explaining the control of the grain size? Do you think it is the original same composition that is having different inorganic content according to the grain size, and then having the Posidonia finally doesn't change that? Or is it that when the Posidonia stabilizes the sand, the smaller inorganic grains do not leave?
The latter.
Okay.
Yeah.
Okay.
Thank you. Your answers are very good. Thank you. So congratulations. We're happy. So congratulations. So, Melissa, we're going to talk about plastic degradation during in the sea. Good for you.
So thank you very much for all being here and for the great presentations that we've heard before. Now I'm going to talk a little bit about materials, and I'm going to do a comparative assessment of material degradation and ecotoxicological effects of different plastic materials in marine environments. So for this, with a little bit of introduction, plastics, they are cheap and they're everywhere, especially in marine environments where 7 out of the 10 most common marine litter items are made of plastics. Being one of these, the plastic bags that when we're doing our shopping may seem fragile, but then when we leave them alone, they're highly persistent. And it's this key characteristic of plastic goods, their durability, which makes them really persistent in different environments, which makes us think as if it's really an advantage or a long-term responsibility. When we think about plastics in the ocean, the first risk that comes into mind is a turtle eating a plastic bag, but this is not the only thing that can affect marine ecosystems. There are over 20 chemical additives, more or less, on every plastic item, and most plastic items have unknown chemical composition. These additives can leach into the aquatic environment, affecting biodiversity and food webs. And another particularity of plastic is they can also absorb persistent organic pollutants that are already in the water, transferring into the trophic web these pollutants that were not accumulated in single cells. So alternatives have arisen, and the industry brought the bioplastics that sound similar but have really different properties. When we talk about bio-based plastic, they come from biomass, which means they come from plants, but they're not biodegradable per se. When we talk about biodegradation, it's a chemical process where microorganisms turn these materials into natural substances using oxygen and releasing CO2. So the best option sounds a bio-based, biodegradable plastics, but even those have really slow degradation rates in marine environments. So this makes marine biodegradation the ultimate test for persistence of these materials. This is why in the recent years they have developed fast protocols to test this marine biodegradation rate by studying the biological oxygen consumed by these microorganisms. Other certifications for bioplastics are the compostables, which is a really trendy label, but it means for a material to be compostable that it should be biodegradable, means leaves no residue and have no ecotoxic effects. But if these materials break down faster, because we don't want them in our own marine ecosystems, they can also release the additives that they have faster into the aquatic environment. And it's studied that biodegradable plastics and alternative materials have way more chemical additives on them than traditional formulations, because we as producers, we want the end product to see the same qualities. And to achieve that, these alternative formulations need more chemical additives. So if they break down faster, so they're releasing faster the additives, and they have way more additives, are they really a safer alternative? Even if we try to live a plastic-free life as consumers, there are still many sectors that rely heavily on plastic use, as is the case of aquaculture, fisheries, or even marine restoration, where some coastal conventional restoration techniques utilize recycled tires, which sounds nice because you're giving it a second life to something that wasn't ready to be discarded, but you're introducing them in marine environments as artificial reef structures. recent years have been discussed how to start using this alternative formulation and bioformulation also in these sectors. So the main aim of this study was to contribute to the understanding of the environmental behavior, biodegradation rates, and ecotoxicological risk associated with different plastic materials in the marine ecosystem. And our main hypothesis was that the biodegradable plastic had lower or comparable ecotoxicological risk to marine invertebrates, while they have a shorter persistent times in this environment. For this, we had to purchase commercially 3 different materials. The first one were conventional polyethylene bags, PE bags, to represent the conventional plastics we all use. Then we had compostable bags that were also certified as biodegradable, and this was our alternative material. And we had a tire granulate that was made from recycled tires, and all of these are materials that we can already encounter in marine environments. The setup in the Mesocosmos at the university facilities of the University of Vigo were 12 tanks in total. We had 3 different treatments and 3 tanks per treatment. Inside of each of the bag treatments, we had 4 bags. And inside of the tire granulate treatment, we had 400 grams of this tire granulate enclosed in mesh bags, so it allowed free exchange of the water without losing any of the material, because it was an open flow setup with unfiltered seawater from the Ria de Vigo. Temperature and light intensity were recorded daily, and all the setup materials for the ensemble or the bags for the tires were previously pre-soaked and flushed, so we don't have any other chemical interaction. The material preparation for the analysis, every time we took something out of the tanks, it was cleaned, dried, and weighted, and then it was micronized to use the less than 250 fraction for the chemical analysis and the biological oxygen dependence, and the less than 1 milliliter fraction for bioassays. The times of retrieval of the materials were at times 7, 14, 28, and day 60. But for ecotoxicological analysis, we only use materials from times 0, 7, and 28. First part was the chemical analysis and hazard identification. For this, we sent subsamples of each material at time 0 to the central services of the university for Fourier transformation and gas chromatography, so we would know what were the base polymers of the materials that we were working with and major components, as well as the organic compounds that were present in them. Then we did a qualitative chemical hazard index. So we had these peaks and we compared them to the university libraries, and then we were able to name them. So now we know with over a 60% match, those were the ones that we took into account, what additives were in our plastic materials, and then we used them to calculate this hazard index that, based on available information about acute and chronic toxicity, endocrine disruption, and other things that affect organisms, to say how toxic hazard they could be. For the biodegradation test, we had 2 approaches. The first one was a Mesocosmos exposure. We put the bags in these frames and just leave them in the water to see how it would evolve over time. And we would take photos before and after retrieval. And then we did the biological oxygen demand test, where we used sediment pore water as a marine inoculum to get some microorganisms, and we cultured them in amber bottles for 28 days with our tested materials that were the compostable bags, because they were the only ones that were said to be biodegradable. The compostable bags at type 0 and at type 7, because we wanted to test if this preconditioning and pre-exposure to a real marine environment would make any difference in the biodegradation rate. For the bioassays, we did a tier 1 approach. This means that we didn't put the micronized material directly into the organisms, but we used the leachate from that. So it was incubated in artificial seawater for 24 hours. And then the test species used were a microalgae, Thesis lutea, where we measured growth inhibition, Paracentrotus libidus, sea urchin, that we measure larval growth, and a Carteclosi, that's a copepod, and we measure survival. All the dilutions tested were undiluted, 1/3, 1/10, and 1/30. And all the data was fed into a product dose response, where we got to calculate the EC10 and EC50. And this is where 10% or 50% in each case of the biological response is hit. Now to the results, starting with the chemical analysis. Here we can see these were the compounds that were identified in the compostable bags. All of them are over 60% of the coincidence, so we're pretty sure that those were in there. And based on the risk, we gave a score. The compostable bags show a really heterogeneous mix that, if we compare to the polyethylene bag that scored 0, because it didn't have any functional additives, you only found more or less like parts of the polymer chain broken down in little pieces. While the tires scored the highest because they had polycyclic aromatic hydrocarbons, and they also had 6-PPD, that's a common additive for antioxidant functions. We go to the mesocosmos exposure, the bags show no biodegradation, they were exactly as we put them in after 60 days, so probably it should be a lower exposure period. And we couldn't take into account initial versus final weight because the only difference that we found in the bags is that encrusted algae was growing in them, so the weight was way different. For the biodegradation, this was really curious, but it actually aligns with literature where we didn't find any biodegradation for the biodegradable bag. As we can see, the oxygen consumption for a positive control, that's a truly marine biodegradable polymer, we did have some, while for our bags, even if they were pre-exposed, didn't show any, and compared to the positive control, it was only at 0.2% of the degradation. For the bioassays, in general, they show the same toxicity patterns, the material, across different species. So I'm just going to mention the highlight parts of each one of the species treatment. For here, this is the microalgae, and we have negative values, and that's the thing that brings into mind when you see it. And this is because we started with an initial population, and with the highest concentrations of each treatment, especially for the tires and a little bit for the compostable bags, we see that this initial population did not only not grow, but it was reduced. We found toxicity in all the tire treatments at different times, at the highest concentrations, and we found some toxicity at the highest concentration of the compostable bag at time 0 and time 28, while at time 7 it was reduced. Probably because the first additives to be leached, they were already washed out of the system. For Acarta clausi, we didn't find any toxicity for the polyethylene bag, either at the beginning or at the end, so we didn't test at time 7, and the rest of the results aligned with the previous one with the microalgae, where the compostable bag showed toxicity at time 0 and time 28, and stopped showing toxicity at time 7. Paracentrotus lividus was the most sensitive test. It did show some toxicity for the polyethylene bag after 28 days, which makes us think that probably the weathering in the marine environment started to leach secondary additives that were not present in the first study. So it would be really interesting to send these samples also to the central services to see what organic compounds would be found in them. But overall, they show a little bit of toxicity in all of the tests. So Acarta clausi, the copper bud, showed the highest initial sensitivity. Paracentrotus lividus was the most sensitive response, even at low concentrations, and Thesis showed the most pronounced temporal variability. If we see this, it aligns with our chemical hazard index that showed that the tires were the most toxic, and we did find toxical response in overall all the times. And the compostable bag was more variable, intermediate value, while the P remained basically inert. For final conclusion and remarks, even if a material is marketed as compostable, it doesn't mean that it's gonna degrade in marine environments or it's not gonna have any toxicity effect. Even transient chemical exposure can affect small planktonic organisms, and that environmental performance is highly variable and context dependent. All of this makes us think that the development of these alternative materials must match the time to study their environmental safety and performance, so we're not replacing one form of persistent and toxicity with another.
Let's improvise. Let's start with you, Eva, and with Heidi after.
Okay, thank you very much. I really enjoyed the presentation because it's a very, very timely topic, and it's very important because we are exposed to plastic all the time, and it's accumulating in the coast, the oceans as our sinks. So it's a very, very good topic. The first question, as for the previous speaker, is about your contribution to this study. That is a very complete study with different measurements and different estimates. So, what part did you do personally?
All of it.
All of it.
Since working the vendors to deliver the materials, to building the setup, keeping track of the stock of the copper pots, building on the setup, doing the biodegradability test, digging for the sediment bore water. I was really present and I really enjoyed it.
Right. And I have a curiosity about the organisms selected for the mesocosmos. Because I course, I understand we have the primary producer, we have the muscles that are filtering organisms, and also the starfish. But I'm curious, did you consider some following organisms that live in the sediment? Because I'd expect that they would be like more exposed to the plastic that can sink and accumulate in the sediment.
This was more of a methodological decision because I wasn't the only one doing my thesis there. I was with my colleague Simon Peters that presented yesterday. So he was the one studying this marine organism while I was focusing on the material characteristics. So he chose these three materials to do like a trophic change effect. But I wasn't in that work. I only focused on the biotoxicological assays and the biodegradation of the materials.
Okay. What could you expect if you added this type of organism? Yeah.
Probably some studies that have done with biodegradable plastics and comparing putting the plastics flat on the sediment and then up in the water column was higher degradation rates in the sediment because there's more microbial activity. So probably if we had included sediment and put the plastics down there, maybe we would have higher degradation rates.
Yeah.
But overall in marine environments, when we do the accelerated protocols that are a really nice way to test this in shorter periods of time, the most materials that were marketed as compostable and biodegradable only achieve a 2 or 3% of biodegradation, which is really not solving the problem of marine litter in the environment.
So they are lying to us.
We're trying to find
Degradable
solutions, but sometimes the industry goes way faster than what science can prove, and it's a bit of like a different overlap in there.
So from your results, how long do you think or could predict you have to wait until seeing actual degradation?
I think I could retire, and I'm not even working, so we didn't see any effect. What could have been interested was to test, for example, tensile strength, to see if any of these mechanical properties in the bag started to degrade, but we didn't test that because we didn't have enough time.
Okay, thank you very much.
Melissa, thanks very much. You speak extremely fast.
Sorry.
I felt like I had to ask you to slow down. But I'll just have a couple of questions. So you said about the label in terms of biodegradable alternatives. So what was the labeling of the plastics that you used for your experiment?
Here. The polyethylene bags, they were food grade and they were just regular polyethylene. They didn't have any extra certifications. The compostable bags were certified as biodegradable. They were used also food grade and they were certified OK home compost, which means that they should be biodegradable, leave no residue, and also be able to degrade in home situations. They didn't need any high temperature or pressure like industry compostable plastics may need.
Does it say that?
Yeah.
Okay. Yeah, that's funny. Yeah, because nowadays, like most of the stuff that we see as compostable is industrially compostable, so it's
No,
a
this
controlled
one was
temperature.
home compost, so it should be
Okay.
their normal conditions.
Yeah, that's interesting. The next thing I wanted to ask you, if you could expand a little bit on your chemical hazard index.
So we send subsamples of the materials for gas chromatography, so we check the main organic compounds that were present in there. But obviously we try to compare the peaks that we got and the retention time to the ones that we had information available on our university library. And when we had a match that it was, okay, so this peak should correspond to this organic compound, that it was over 60%, we would say, okay, this is this organic compound. And then we only did, it was a qualitative analysis. We didn't take into account how much percentage of this compound could be in our material. We just checked presence and absence. And we looked for information on data sets like PubMed, National Library of Medicine, to see risk for aquatic toxicity, chronic toxicity, endocrine disruption functions. And based on that, we gave this score. This is a paper from my supervisor that we were following. So, in general, more heterogeneous mixture, higher scores than more simple mixture like the normal polyethylene bag that didn't have any chemical with a risk associated to it.
Okay, and then when you had your bioassays, I'm just trying to trace you back, okay? So when you had your bioassays, when you're looking at toxicity, you're using at this index as well?
No, when we're doing the bioassays, we're following standard toxicity protocols. So we were just checking that our concentration here. We're doing a bioassays, we're checking on the EC10 and EC50. So when we have a 10% reduction of the biological response or 50% reduction, and based on that, we assign another toxic category. So it was like none, like low, medium, or high.
Perfect, thank you.
Thanks for your talk. I'm amazed at the quantity of work that you did during your thesis. It's really a lot. And the way you present it, I think it's difficult for the audience to follow you because you speak fast, but also some things on the slide are hard to read. So I will ask you to help us with
Sure.
it, okay, so that we can. So first of all, I would like to go back to the index again, and I would, yes. So you see there are three chromatograms here. Do they correspond to the three plastics like E at the
Yeah,
top?
I just put them like this to show what the peaks were like, but these are actually the results from the chromatographs. This one is for the polyethylene bag, that we just see a couple of peaks. This is for the tire granulate, and this is for the compostable bag.
Okay. Did you just how did you extract the material? Did you just expose the material to some solvent?
For the chemical analysis, we use the materials at time 0, so they weren't exposed. And
Yes.
we send them for gas chromatography, the less than 250 fraction for analysis at the central services of the university. And they gave us back the results.
Yes, but what was injected in the gas chromatogram? Was it like a solvent extract?
Probably an organic solvent, because we were looking for organic compounds.
Okay. You don't know which one?
I don't know.
Okay. Then you have those results effectively, and the compound are well identified. But it's only the frequent absence and the ecotoxicological potential that you use to draw the index. Can you comment on that? What is the real toxic effect of a compound? Like when you do your leachate exposure, you dilute the leachate in various concentration, like 10 times, 100 times. So can you have a critical view on not including the quantity in the index, for instance?
This was just to know what chemicals we had, more or less, to have a better overview of the product that we were working with in the materials. The leachate was prepared from the materials
Yes.
itself, so we aim for a 10 milligrams per liter for the leachate.
Mhm.
And then, so we don't know exactly the concentration of these additives that made it into the leachate. We just know that's the leachate from the material.
That was not my question. But really, I would like you to have a critical view on the index.
Yeah, of
Because
course.
it's not really an ecotoxicological index.
No, of course, it was just like a preliminary assessment. Of course, we also have the possibility to quantify these peaks and the area they occupy from each material, but we didn't have enough time to do that. That's
Okay.
going to be on previous, like, future studies. We're going to keep working on it.
Yes. Okay. Excellent. Because quantity matters in terms of.
Yeah, no, of course.
Okay. Excellent. Okay. So now, if the leachate experiments are really, it's perfect. I think. It's like several organisms are tested, several concentration. You got the EC from the test. It's really nice. And when you look at the
results for the different material, you went so fast. It's like those results. You see, we cannot read the graphic. It's too bad because your results are really amazing. But clearly, it is the tires that are super more. Yes. Give us an idea of what is in the tires that is not in the polyethylene bag, and that
So
could explain that.
probably it's because the tires had different functional additives. For example, when I mentioned beforehand the 6-PPD, that's an additive that's really common in tire compositions. It's an antioxidant, and because we want the tires to have all these properties to be resistant, high temperatures, low temperatures, and wear time, more wear time, they have way more functional additives that can be more toxic, and they are more persistent in marine ecosystems.
Yes.
And this is really interesting because even though that we have a lot of regulations for toxicity and for plastics and try to introduce all these new alternative materials, in the same time, there are several places when they're utilizing this tire granulate because it's made from recycled tires and we're giving it a second life. And they implement it in artificial turf fields, in kids' parks, and all these places where you shouldn't expect to have a material that shows toxicity. So more studies should be done to really assess the potential risk of this material.
We came good to it.
Yeah, it's good. I would stay with this graph actually, but first congratulate you for your study. It's impressive also that you try to focus on the multiple aspects of this research, and this is really nice. But I would also like to understand a bit what is happening here, because from my understanding, what we are looking there is the biological component, no? It seems no problem to me, more or less, with the plastic that is tested here, more or less no significant result, right? Or am I getting it wrong?
So here we have our concentrations, and each graph is a different time, and each color is a different material.
Yes.
And
Except for tires, which is
except for tires, but the most relevant thing here is that we might think that after the first 7 days of exposure, the materials are chemically inert. They already leached everything that they could have that have any toxicity. But as we can see, it starts again at day 28, probably a few days before, but we tested at day 28. So what I wanted to show is that even though we think that a material has really low toxicity, and for example at time 0 the compostable bags only show toxicity at the highest concentration, when it's exposed over time, toxicity may rise, because here we have also significant toxicity results at time 28 for concentration 1/3. So this could mean that even though it's a little bit and it's not really a big response, we don't have negative values, it's not killing the population, but it still has an effect, and it has an effect especially on the smaller organisms that are the base of the trophic web.
Yeah, right. That's very correct. Also regarding the organism, you did measure growth, right? You measured the body size, or
Yeah,
is
for
that
the
correct?
sea urchins, we compared the egg diameter. We did in vitro fertilization. We compared the egg diameter at the beginning to the final size after 48 hours.
Mm-hmm. So it's basically growth, different ways to measure growth. Would you consider, let's say, you have time for a bigger project related to that and do more dedicated experiments? What else would you consider to measure for the organisms, for the biological component, to see the effect of
Well,
the
for example, for the algae, it would be really interesting to measure photosynthetic activity to see if they had any effect on it. Also, for the sea urchin larvae, if we had any deformities or malformations or like thinner walls in the embryos. And for the copepods, besides survival, mobility was affected in any way.
Yeah, because I'm thinking that sometimes depending on the parameter that you measure, that you're checking, that if you see the effect in time. Sometimes it takes longer for certain parameters that you see the effect of toxicity or any other stressor. And yeah, for chemicals, for example, I would see reproduction, for example.
That would be really
something
interesting
that-
to test, but in the lab that I was working on, the reproduction was mainly tested on Daphnia magna, which is a freshwater organism, and we didn't include it in this study. But there have been studies with thyroid particles in reproduction of Daphnia magna, survival, and motility, and these were done in 28 days as a chronic toxicity test. And the thyroid particles also show significant results. Endocrine disruption.
Yeah, it's interesting. But I just want to say, like, you left us wondering how long it takes for this degradable bug to degrade. And I think we will stay with this question because, or we do tests at home. Maybe we do some tests at home.
Congratulations.
Thank you very much.
Ella, Melissa, thank you for the questions and enjoy the coffee break. And the last presentation, I'm sure you will be there to support. Were you able to get?
Yes.
I completely messed up my notes. I picked up the student from room 1 in my notes. Oops. I thought I was gonna see.
We're live.
Can I time with my?
I was here before she went to.
Thank you.
We're gonna wait just a minute. I'll do a general presentation. But we welcome everyone to this last presentation with the most resilient of our students that have all done for this 1.5 past day, and now I get their chance to shine in this last session. I'm Olivier Gauthier, as you know by now, I guess, from UBO. I will be chairing this session. With us sitting as members of the jury, we have Dr. Katie O'Dwyer from ATU, Dr. Pelle Arbeck from U Gothenburg, and Dr. Martina Kopari from UNIFPM in Ancona. So, as you know, you have 15 minutes to present. And when you get to the 12-minute mark, I will wave 3 fingers just to let you know that you have to start thinking about closing up. And if you see me getting up, is that you have taken all of your time and you need to wrap it up very, very rapidly. But I haven't seen this happen in the past days, so I'm confident it's not going to happen. So we just maybe wait a few seconds so that people online that want to maybe join at 11:30 are there, because it's not exactly 11:30. And then I'll give you the floor. You can start. Beatrice, whenever you're ready.
Okay, so hello everyone, my name is Beatrice and I'm here to present you my thesis that I did with Coral Reef Alliance, where I studied the influence of water quality parameters on the Mesoamerican reef health indicators. So to start, I would like to introduce you to the world's coral reefs and to share a fun fact about them with you. They only represent 0.1% of the ocean surface, yet they're home for more than 25% of all known fish species. So they are major harbors of biodiversity on Earth. And if you look at this greenish zone, that is the Caribbean, you'll find the Mesoamerican Reef, or MAR. And the MAR is pretty cool because it's the longest reef of the Northern Hemisphere, and globally it's second only to the Great Barrier Reef. It directly supports 1 million people through its ecosystem services, and the links between coastal communities and reef are not only through the services, but they are also physical, with the more than 400 watersheds that we count from Mexico to Honduras. So clearly there are some critical linkages between land and sea in Mesoamerica. And half of my images are gone, but it's a very intertwined system. Here there's a village, and here there's divers and boats. And when the reef is healthy, normally there's a lot of corals here, it's going to promote the ecosystem services that are going to promote the coastal development. But coastal communities also exert a pressure on the reef and the ocean in general, mainly through the runoff of fresh water. And if these pressures are too heavy, the reef, there's not going to be corals, they're going to be unhealthy, and the ecosystem services are less supported. So it's a cycle, it's a you get what you keep system. Yes, off of the propaganda, sorry. And luckily, a group of scientists understood that it's pretty important to make sure that this reef stays healthy, not only for conservation and biodiversity purposes, but also because the sustainability of the coastal communities depends on the health of this reef. And this group of scientists created the Atlantic and Gulf Reef Rapid Assessment, or AGRA, that has been doing biannual assessments of reef health ever since 1997. And they measure many indicators, and among those, they measure the benthic cover and the fish biomass. And those are indicators that make a lot of sense because corals live on the benthos and fish live on the corals. However, I was quite surprised to, yes, there's also not images here, but I was surprised to find out that most studies in the Mesoamerican Reef that focus on water quality parameters are using satellite-derived proxies, and these proxies are not very adapted for the small-scale variations that we can see. Luckily, in 2021, the first water quality sampling campaign was done, and this was the first time fine-scale water quality parameters were sampled in the Mesoamerican Reef. And was this sampling campaign that sparked my research question, which water quality parameters influence reef health the most? And through the answers of my research question, I hope to assess the influence of abiotic factors on reef health in order to provide fine-scale predictory models of reef condition that hopefully will help to adapt small-scale conservation measures instead of having a one-size-fits-all for all the length of the Mesoamerican Reef. So, as I was just saying, I started with two different sampling campaigns, so with two different data sets, one for the reef health and one for water quality, both from 2021. I matched their sampling points spatially and temporally to end up with my final data set for analysis of 24 sampling points from August to December 2021. And here on map A, you can see the 24 sampling points, and precisely I had 8 sampling points in Mexico that you can see on map B and C, 10 sampling points in Belize that you can see on map C, and 6 sampling points in Honduras that you can see on map D around the island of Roatan. Then I picked my main variables. Specifically, I picked 5 main reef health indicators: live coral cover, turf algae cover, fleshy macroalgae cover, commercially significant species biomass, and herbivore species biomass. And then I picked 7 main water quality parameters: temperature, salinity, pH, dissolved oxygen, nitrate and phosphorus concentrations, and distance to shore. Then, to answer my question, I thought of modeling. So with these elements, for each reef health indicator, I picked 4 to 5 potential predictors from the previous list, and my selection was based on the pairwise tests I did as preliminary analysis. With these elements selected, I fitted them into multiple linear regression models with the reef health indicator as a response variable and the potential predictors as different combinations of additive terms of a regression model. And I statistically checked for the performance of these models. My final model that I picked had to be statistically sound, but also had to make sense ecologically speaking to the reef health indicator of interest. With this final model picked, I would analyze the residuals, and if I noticed curvature in one or many terms, I would fit the same formula into a generalized additive model, but with a smooth term in the nonlinear terms, and also check for the statistical performance. And no matter which model I picked, my output would always be the same. That's to say, the answer to my question, I would have 2 to 3 main water quality drivers of the reef health indicator of interest. Now, if you're following me until now, you may guess that I have 5 answers to my research question because I showed you before I have 5 reef health indicators. And if you guessed this, you're very right. So, starting with my first indicator, live coral cover. The model for live coral cover predicted a higher cover of corals under conditions of higher salinity and lower pH. And I don't know about you, but when I first saw this, I was really worried about my models because for me, higher salinity and lower pH translate to ocean acidification conditions. So I started to take each a term individually to try to understand a little bit more of the ecological context, and you're gonna see this is something I did for most of my reef health indicators. So starting with pH. As you all know, corals are animals, and animals go through metabolic processes, and in corals are more or less summarized into net ecosystem calcification, or NEC, and net ecosystem production, or NEP. NEC is a balance between calcification and dissolution, and NEP is a balance between photosynthesis and respiration. Calcification and respiration have been previously proven to decrease the environmental pH within a reasonable threshold, of course. And given our short-term data set and also the short variability of my pH values of 0.25, I hypothesized that my term in this model is reflecting rather of the short-term natural variability of a healthy community rather than the long-term consequences of a chronic effect like ocean acidification. The same way, salinity, I don't think salinity is acting alone, as it may be acting as a proxy for the effects of runoff. So, if you remember my incomplete drawing of earlier during the introduction, you saw the runoff of fresh water. And logically, fresh water is going to be in higher concentrations closer to shore and lower the seawater salinity. But that's not the only thing fresh water does, right? Fresh water brings anthropogenic contaminants that are deleterious for the growth of corals. So in my model, I hypothesized that higher salinity is relating to higher coral cover because it's also relating to lower anthropogenic contaminants. Yes. And if you don't trust me, we can go on the next indicator that completes a little bit what I just said. The model for turf algae cover predicted a higher cover of turf algae under conditions closer to shore with higher phosphorus concentrations. And this is nothing else than the effect of runoff. We see more turf algae closer to shore because the distance to shore effect acts as a proxy for the land-based pressures we were just talking about. And it causes phase shifts towards algal-dominated states. And it also makes a lot of sense that out of all of our terms, a nutrient like phosphorus is very responsive to turf algae cover because previously studies have proven that turf algae is the most responsive anti-group to nutrient enrichment. The same way, the model for fleshy macroalgae cover related to not one, but two nutrients along with the pH effect. And precisely, the model predicted a higher cover of fleshy macroalgae under conditions of higher pH, higher nitrate, but lower phosphorus. Higher pH is really nice because it complements our result for live coral cover. And higher nitrate and lower phosphorus reflect of the stoichiometry relationship of these two nutrients in the water. And this has a name, it's the Redfield ratio, the ratio between nitrogen and phosphorus in the water. Now, fish biomass. Fish biomass as reef health indicators are less direct forms of understanding how healthy the reef is, but they're also really important, especially given our previous results, because they provide us a complete picture of the ecological context. So, starting with the commercially significant species biomass, the model predicted a higher biomass of these species under conditions of higher dissolved oxygen concentrations closer to shore. Higher dissolved oxygen makes a lot of sense for me because fish breathe, but closer to shore, given everything I've been just telling you about, is a little curious. So let's start with the distance to shore effect. So this is a map of what you may now know is the Mesoamerican Reef, and precisely the marine protected areas of the Mesoamerican Reef. And they are divided into 3 zones, and I want you to look specifically at the fully protected zones that are in bright pink. These zones are fully protected because they are constantly patrolled, if not daily, weekly. And because they are constantly patrolled, they need to be easy of access. So you find them usually closer to shore. And in these zones that only represent 7% of all the Mars MPAs, the grouper and snapper biomass have been measured to be up to 10 times higher in biomass compared to the other zones of the MPAs. So it makes sense that in our model, the term closer to shore relates to higher fish biomass. And when complemented with the second term of dissolved oxygen, makes this model a lot more suitable, because what's better than a fully protected MPA to reflect of a well-flushed, productive, and healthy environment. Moving on to our last indicator, herbivore species biomass. This model related to distance to shore, but also to temperature, and the twist is that herbivore species biomass was best described by a generalized additive model with a smooth effect on both terms. And precisely, the model predicted higher herbivore species biomass in temperatures between 29 and 30 degrees at a distance to shore up to 1.2 kilometers. And the temperature effect is nice because it gives us a thermal range, but other studies have already proven that within herbivores, the thermal range varies. So it can be considered as a limitation in our study, but also can help explain why we see some curvature. And to the distance to shore effect, it can be explained to the results of the previous biomass model, but also it can just be simply acting as a proxy for the gradient of food availability, because if you remember the model of the turf algae cover was expected to be higher closer to shore, and herbivores eat algae. So to conclude, my study used exclusively in situ data. And in situ data is pretty cool because it captures small-scale variability and short-term dynamics that satellite proxies cannot do. And this is even more special in the Mesoamerican Reef, because this was the first time that we did a fine-scale assessment of the impacts of water quality on the reef health. And this is important because it's going to give targeted and localized and small-scale indications for the next conservation measures. However, because it was the first time using such in situ sampling data, we also had a quite small sample size, so the predictors were not always ecologically straightforward. But if anything, the main takeaway from my research is that we need to keep sampling, we need to keep working on it, so the models that we build from this data keep getting stronger and stronger, and instead of having just hypotheses like I show you now, we can have actual conclusions. Yeah, so this is my references, and thank you so much.
Thank you, Beatrice. Very, very dynamic and very interesting. A very good storytelling skills, I must say. This was really entertaining. You are 3 members in the jury, so I will try to give you 4 minutes each, and then we have some wiggle time. Someone wants to go first, maybe? Okay?
Yeah,
Sure.
yeah.
All right.
Thanks very much. Nice presentation and really interesting results and very clearly presented. It's not a topic that I'm super familiar with, so I have a few questions and you can see how we go. So one was, you talked about the Redfield ratio and the high fleshy algae.
Yeah.
I was just wondering if you can explain a little bit more what that is and why it matters for the algae, like what the nitrogen and phosphorus ratio.
Okay, so from what I understood, the Redfield ratio is the ratio between nitrogen and phosphorus. And when phosphorus is in limiting conditions, it promotes the growth of algal-dominated states. It has an effect on the resilience of corals. On fleshy macroalgae specifically, there are no studies. It's more about turf algae, because turf algae are a particularly interesting benthic group, because at a small proportions, they actually help the growth of corals, but when they turn into algal mats, they are deleterious. So there are a lot of studies on the Redfield ratio for turf algae, but not really for fleshy macroalgae. So I assumed that it may be acting the same way, because it was a curious trend compared to the other. It didn't make sense at first when I was first analyzing it, why one would be bad for the cover and one would be increasing the cover. And then my advisor suggested me about the ratio, and it is indeed a ratio, and the concentrations of nitrate compared to phosphorus in the Mesoamerican Reef are very, very different. So it's just an hypothesis.
And could you use, without knowing about the Redfield ratio, could you use the data that you have to create a ratio and look at that? Like from, do you have these measurements from the same time point, same location? You could actually
Yeah.
calculate the ratio
I
and then
actually-
analyze that.
That's what we tried. I mean,
Okay.
we first tried this, and then when we saw it could be a
Yes.
ratio, we tried to do that.
Yeah.
But my main problem throughout this analysis was that I had a very small sample size,
Yeah.
and adding a ratio would also add uncertainty to the model. So we preferred having just the
Stick
raw
with the
values.
raw data. Yeah, that's fair. Yeah. And then actually that kind of leads me to one of the questions. So you mentioned this, your data was based on a 2021 campaign.
Yeah.
Is the campaign going to happen again, or has it happened since, or what's going to be the plan for
Yeah.
ongoing data collection?
At such a large scale, because there was many organizations that agreed on working during the year of 2021. It hasn't happened yet, to my knowledge. They are using the same protocols in Mexico, in Belize, and in Honduras still, but kind of discoordinated. And I think this is a huge lag because, especially at first, I was trying to work on satellite data, and we realized the satellite data was not good at all, especially for the small variations of the small islands of the Caribbean. And then we tried to work with these, but there's still a lot of data lacking still because, this was the first try, and hopefully there will be more.
Okay. Is there time for one? Yeah. So just based on that, I was also wondering actually about this satellite data and the data from the 2021 campaign.
Yeah.
You looked a bit at the satellite data, then it sounds like I was wondering if you think there is any way to look at the two data sets and see is there any indicators or something that can be used from the satellite data in the absence of ongoing campaigns?
My first question was about comparing satellite data with in situ data, and from the little data I had, my model showed that satellite data was not adapted at all. So that's why I didn't decide to not put it out on the thesis.
Okay.
But also it can be because there's very little data. Like that's also the problem.
And now that you have more analysis, maybe it's worth it.
Yeah, maybe. Yeah.
Okay. Thanks very much.
Thank you.
Valentina, you wanna go?
Okay. So one is more a curiosity, not a clear question. The other is question related with the implication of your thesis for management. I mean, in the last slide you said that this thesis could help for localized management strategies.
Yeah.
What do you mean exactly with this? I mean, how your thesis could at localized, really small scale, help managers to improve the action or the measures?
Well, the Mesoamerican Reef is enormous, and there are a lot of countries, and they have different dynamics. And I was in Honduras, I was in Guatan, and just in Guatan, compared to the coast of Honduras, of continental Honduras, there is already a huge difference in the coral composition and in just water pollution, because Guatan is a very touristic island, a lot of cruises pass by there, and this zone of Honduras is more exposed to the ocean, and it's less touristic, so less pollution happens there. So I think it's important to analyze at a small scale the impact of the water on the reef, because all of these countries have different dynamics. So it would help, for example, if an association in Honduras was noticing that would be a high concentration of phosphorus in their coasts, they would expect more algae, and so they would know how to counter that in comparison to somewhere else that is more wild, you know.
And if I correctly understood, you did not directly participate on the sampling and the collection of the data, right? You got data from different campaigns.
Yeah, that was in 2021. I did help. I helped a small association in Guatan for water sampling, and I had the chance to participate in agro sampling, but for 2027. So I know the methods, but I was not there in 2021.
Okay. Thank you.
So? Okay, Pelle?
Yeah, thank you for a really interesting talk. I wonder, some of the things that you mentioned, like macro cover or the biomass of fish.
Mhm.
It goes from one end to another. What is good and what is bad for the reef? I don't understand. What is this? Just some kind of natural variation that you're looking at?
Like, why did I pick these indicators?
No, but I would like to see a little bit more about. Well, if you have a lot of turf algae, that's bad, I guess.
Yeah.
But is it really bad in the end that you see, or is it like, well, everything is like normal?
Yeah.
So is it really good or bad conditions?
Yeah. If I had more time to explain, I wouldn't present it the way I did. I would actually give the context of each indicator. I think yeah, that's interesting. Turf algae precisely. I was surprised to know. My advisor told me that turf algae in small percentages of cover around corals is actually beneficial because it attracts herbivore fish. When they turn into algal mats, and I don't know the threshold of the percentage exactly, but when they turn into mats, they start taking place on the corals, and the corals start to die.
Yeah. But
So-
do you have that end in your data set? That's would have been interesting to know.
Like the
Yeah,
threshold.
because here you have live coral, but what's good and what's bad anyway.
Like the thresholds.
Yeah.
Yeah, that I don't know. Yeah, that's actually a good question.
And then when it comes to the parameters, abiotic parameters, could you find other parameters that you would have liked to use instead of the ones that are using?
There is one that I would love to use, but there was not enough data at all. Turbidity.
Okay.
I would think it's really interesting. For example, when I was in Honduras, there was a crisis of sargassum that beached on the beaches, and that was also really interesting because when I was diving, it would completely cloud the water, the sun rays, and I think that might have an effect for sure on either on turf algae or algae in general and the corals, but I didn't have that data.
What about runoff?
True. Yeah.
Because you said several
Yes.
times that
Yes.
this is dependent on runoff, but there's no data on that, or
Yeah. No. Well, from these data sets, no. They probably measure it. I was not given that kind of data.
do you know anything about the trend of the runoff?
I know Roatan.
If it's increasing or decreasing over time?
I know Roatan has a very weird high levels of phosphate around here, and they don't know why. Compared to the other islands of the Bay Islands, and they are really intrigued about it. And I even saw it in the satellite analysis that I did beforehand. No one can really explain why.
Thank you.
All right, thank you, Peter. Well, since I have time, I will ask a few questions. Just related to that, a comment. In a previous PhD student of ours working on benthic communities around Brittany, to try to see what the land usage on the coast was doing, she managed to evaluate the size of the watersheds. You realize that geographers don't really call them watersheds if they're emptying directly on the coast, that were influencing the points, and then try to look, as we had that information in France, try to look at what kind of activities were taking place. That was actually quite useful. That it was a snapshot to interpret the time series, but it was still quite useful to look at. I was wondering, you mentioned that you're using like different data source, which is great. You said you looked for a spatial and temporal match to build up your data set. What were your criteria to select the sampling dates and sites?
So, I wanted to maximize the amount of data, the sampling points I have, because as you can see, it's not a lot. So I tried to match them exactly first, and that was only, not a lot. So, temporally, I picked the water quality data up to 90 days before the sampling campaign of the reef health, because I mean it has to be before. And for the spatial data, I picked within a 10-kilometer uninterrupted radius. And if, for example, this is the reef data and this is the water quality data, I picked the radius, and if they would fall within the radius, I would. That for me would be a spatial match.
Okay.
So that's how I did it.
Yeah, that makes sense. And related to you had many variables that you did not use, you did not take into account. Then, what were your criteria for not taking them, and what kind of variables, what other variables you had and you discarded?
Just the ones that were not measured, that I didn't have enough measures, because
It was simply a technical, not it's not. Oh, this is not interesting for me, so I'm not going to take it.
Because I knew I had very little sample size, I wanted to maximize the amount of predictors I could feed. And turbidity was one that was really interesting, but I think it was not measured in Mexico, so I didn't want to discard Mexico, so I discarded turbidity.
Okay, maybe just one question on the small part of the result. Can you go to the first graph you showed, and you discussed I really like, by the way you integrated the presentation of the model results and the critical view on it and the interpretation. It's nice to see that happening at the same time. One thing I don't think you mentioned is in the salinity values. Well, you have most values are between 3.6 and 3.65 PSU, and then you have these two at the other end. Do you think you have a good view of the effect of salinity on the coral cover with this?
Yeah, this was a really huge problem when we were on the analysis with my advisor. We debated a lot about the term of salinity because of these values. That's still the same problem. They are very some of my data is skewed, and
that's the worst case. And it's not just the skewness so much as the gap and then these two values.
Yeah.
I don't know if you tried to run them out. I know you have only 24 points, but did you try running it without these two?
Yeah, but then I felt bad because.
No, but did it change the relationship for the other variables, or did
No, the trend was still the same.
And did you still have something for salinity?
The trend,
these?
the general trend?
Yeah.
Yeah, that was still the same. Yeah.
Right.
Yeah.
Thank you very much. Well done.
Thank you.
Up next is David. David, whenever you're ready, you have 15 minutes.
Hello everyone, my name is David Astor. I'm here to present my thesis on fishery and marine spatial planning, specifically in excess fishing grounds and competition for space in the case of Belgian fisheries. This work was supervised by Dr. Geert van Hoy and also Kevin Bell. Now to give you a global context of why fisheries matter, we see here that fisheries has improved in fishery production all the way from 90 million tons in 1950 to 185 million tons in 2022. Also, it helped to provide up to 3.6 million people jobs within the capture fishery sector. And also, 3.2 billion people also rely on aquatic food as a major source of protein. It also helped for the contribution of sustainable development goals directly within the SDG 14. In cases of climate change, environmental degradation, and also resource competition, we've seen areas whereby this has created challenges for fish production. And fisheries has actually helped to, and is also active in the aspect whereby to contribute to food security in line with the development goals, in line with the population increase of 9 billion people by 2050. Now for the Belgian fiscal context, we see that it has up to 64 active vessels. However, this has been declining for previous years. And also, the Belgian fisheries is all dominated by beam and also the demersal fleet, which targets sole and place species. And also, fishery activity is not only limited within the Belgian fishery area, also within the North Sea. Also within the North Sea, Irish Atlantic Sea, English Channel, and also the Bay of Biscay. Because of this wide geographical landscape is what creates a problem or challenge for fisheries, whereby there's rapid expansion of offshore wind farms. Also, EU tends to push its target for the 30 by 30 MPA, and this has led for fisheries to be underrepresented in MSP, whereby as a mobile fleet structure, it then tends to compete with fixed marine users. And then North Sea, which is one of the most complicated or contested marine areas, is then also the major Belgian catch area for Belgian fisheries, which then leads to growing competition for fishing space. This is what led me to my aim, whereby I want to identify and characterize essential fishing grounds of the Belgian fleets using VMS data of 16 years. And this is structured within 4 research questions of how can EFG be identified, 2, how does spatial resolution influence EFG identification, 3, how do MPs and offshore wind farms also overlap with these EFGs, 4thly, and how do all these results contribute to GeoV's platform to participate for MSP in Belgian fishery sector. For my data analysis or my methodology, I use VMS data ranging from 16 years, from 2008 to 2053, whereby also using RStudio, I also have spatial resolutions ranging from coarse to fine scales of ISIS rectangles, C-squares, and also 1 kilometer grids. Thirdly, I have fishing metrics of value of landings, fishing hours, and also landed weights. And for my spatial computation analysis, I had layers of offshore wind farm and also natural 2000 layers. Now, one of the main core methodologies of EFG mapping is seen within 4 steps. Firstly, spatial aggregation, whereby I aggregated the fishing data into grid cells and I summed the total of all fishing metrics from value, weight, and hours. Secondly, I ranked them from highest to the lowest, whereby, example, for value of landings, I ranked the areas which had one of the highest euros, I gave one of the highest euros from highest to lowest. And then I calculated cumulative percentage, whereby I added up from the top till 90% is reached. And then 90% is then classified as my essential fishing grounds. So essentially, what I want to show here is that I want to systematically identify grid cells with the highest value, covering up to 90% of the space, 90% of the least amount of space. And this work was attributed from, or gotten from Nozeka reports, whereby I adapted it to my report. Now, for my first results, EFG identification, I have 2 analyses. First of all, fluid points analysis, which shows the spatial footprint and constitutional patterns of the Belgian fisheries within the 4 areas. And here you can see is the average fishing activity per year. And here, within the study time period. And here you see that fishing activity is not evenly distributed, but however, seen in concentrated corridors around the southern North Sea, English Channel, and also Irish Celtic Sea and the Bay of Biscay. Secondly, I have the percent analysis whereby this quantifies how frequently each spatial unit was classified as essential within the top 90% of the study time period. And for my map here, under the value of landings, you can see the legend, it shows from 0 to 16 in a number of years. 0 means that there was fishing activity within the area, but this wasn't included within the top 90%. However, 1 to 16 means that these were areas which are included within the study time period in the given years. Secondly, this is also a persistent map, but this is categorized within groups, and this shows at least 4 years during the study time period. For my results for EFG application, I got to see that on an average of 8,952 C-squares fished within Northeast Atlantic, up to 35% of C-squares were classified as EFGs. So this shows that how a small population area can have the highest values. For my second results, I have the effects of spatial resolution, whereby here you can see how spatial resolution changes the whole picture. And here for the value of landings across all 4 regions, we see how ISIS rectangle also produces the largest EFG coverage due to their coarse scales, whereby final resolutions produce more precise and small spatial outputs. And over here for the North Sea, we see how it ranges from 205,000 square kilometers of EXG extent, and it shrinks all the way to 1 kilo all the way to 80,000 kilometers within 1 kilometer. This was consistent for English Channel and also Bay of Biscay. However, there was a contrast for Irish and Celtic Sea, which had a higher EFG extent of 30,000 square kilometers under 1 kilometer, but a lower EFG extent for 25,000 square kilometer. So this can say that this is the dispersed nature of the fishing activity within the area. And over here you can see that this is the EFG locations for both the North Sea and Irish and Celtic Sea. I'd like to point over here that beneath here you can see that here is like for Belgium, above is Norway, and over here is the Doggerbank area for the EFG. But it's way more pronounced within the C square than the 1 kilometer grid, and it's kind of a patchy smooth output. This for 1 kilometer, this for C square, this for ISIS resolution. And same applies to Irish and Celtic Sea. For my spatial computation analysis, I had two analyses, progressive analysis and also Bayesian analysis. For my progressive analysis, this shows the year-by-year progression of fishing ground reduction, whereby when offshore wind farms are built and then become operational. So that means as offshore wind farms become operational, there again there is effects in fishing activity. And here, for example, we see here is the North Sea fishing hours. And across all resolutions, there was similar decline from ISIS to 1 kilometer of fishing hours within offshore wind farms. But then again, when compared to the total regional hours, we also see a similar decline of 51%. However, the proportion of hours within the offshore wind farm area represents only a small proportion of the total regional hours, whereby in 2008, there were 5 offshore wind farms, and this represents 5.3% in 2008, and then declines up to 0.7% by 2023. For the Irish and Celtic Sea, it also follows the same analogy, whereby there was a decline also in fishing hours within the offshore wind farm areas. However, there was an increase of total regional hours of 34%. And the same thing also applies that fishing hours within offshore wind farm areas also consists of a small amount of the total regional hours. And this now is my Bayesian analysis, whereby this shows the net magnitude of change of fishing activity between two average time periods. First of all, the offshore wind farm pre-expansion period, we ranged from 2008 to 2012. This is a period before major wind farm expansion, with the impact period, which ranges from 2013 to 2015, that shows a period of major wind farm expansion. And here we saw that Irish and Celtic Sea also experienced greater decline in fishing activity in fishing activity than the North Sea. And here we have the baseline metric trend, which shows the order of decline, all the way from hours to weight, whereby in hours under the North Sea, we have a steep decline of 34%, all the way to 61%, which is the least decline in weight. And here we can say that fishing activities still produce catches, but in less likely profitable areas. However, for Irish and Celtic Sea, there was a contrast. Fishing hours still remained one of the steepest declines, and then Euros the least. And here we can say that although catches decreased, economic returns were still maintained. Now for my EFG NP intersection, I have here the map of all the natural 2000 layers within Northeast Atlantic, and here the North Sea shows to be one of the most highly congested EFG areas, whereby it has one of the most NPA footprints of more than 14,000, but with the least EFG capture of 33%. However, with Irish and Celtic Sea, which has one of the smallest NPA footprints of 27,000 square kilometers, has one of the highest EFG capture. And thirdly comes with Bay of Biscay, secondly, of 33%. Here we can see that the extent of EFG overlap depends more on where these NPAs are designated than the total protected size. And now for my discussion highlights, I would like to say that resolution matters, but it depends on fishery structure, whereby we're saying that C-square presents best for most regions because it reduces the overestimation of axis rectangles, whereby it overlaps high intensity regions and also low intensity regions together to give a core scale size. But however, with C-square, it shows a kind of similar output with 1 kilometer grids. And we see that from the Irish and Celtic Sea anomaly, that final may not always be the better for MSP plants. For offshore wind farm effects, it is real, but however, it constitutes to be only a small proportion of total regional hours. As we've seen for the North Sea, that has it constitutes to be a 5% decline of the North Sea fishing hours within 2008. Thirdly, we can see a possible displacement signal, whereby HSLTC increased all the way to 34% in the total regional hours, which is against offshore wind farm decline. And this may also suggest spatial redistribution. However, I want to be careful here because this could also mean effects by climate change redistribution, whereby if there's a change in climate change, then species may also move around to certain places. Fourthly, NPA location also matters more and important than size, whereby HSLTC, which constitutes to be one of the smallest NPA footprint, had one of the highest EFG capture. And this should take into account into spatial designs for fisheries conflicts. Now for my production and limitation, I here use 2023 offshore wind farm footprint as a constant spatial reference. Secondly, analysis was only conducted within fleet level only. Thirdly, this didn't model at all effort distribution after displacement. And now future research to track where displaced fishing efforts relocates, assess impacts by gear type, and also incorporate socioeconomic dimensions into EFG assessment so as to update EFGs to account for climate and also update EFGs to account for climate-driven shift in fisheries. My conclusions, to reiterate, I here for my first research question, we see that 35% of sea squares account for 90% of the annual activity, whereby a small proportion of area still consists to be one of the highest values. For my second research question, sea square resolution offers one of the best balance for MSP, where we're seeing that it reduces the overestimation for ISIS rectangles and also gives a close spatial output for 1 kilometer width too. And however, resolution effects are also region specific. For the third, North Sea and RUC also show strong displacement signals, whereby for Bay of Biscay and English Channel, they tend to show no or limited interaction with these fixed marine users. And NPA spatial location matters more than the total coverage. Fourthly, spatial precise EFG maps are empirical for foundation of geofish platform, whereby we support evidence-based fisheries as a representation for MSP within the Belgian sector. Thank you, and questions?
Well, that's very dynamic and very good use of your time. Who wants to go first?
I can start this time.
All right.
Yeah. Thank you for a really interesting talk. When it comes to the fishing effort, you measure it in 3 ways. Biomass, euro, and time, basically. But what's the difference between these measures? Or which one is the best? Or what do they tell you?
So it's not about which is the best, because if you want to use a certain fishing metric, it depends on the kind of question you want to answer.
Yeah.
For this research, I use mostly fishing value of landings to show most of the outputs as a proxy of economic returns for the regional fisheries mostly. And I understand that yes, that in areas whereby hours and weights may also be the highest, that's acknowledged. But for this, I just use the value of landings as a proxy for the economic.
Because then that depends on the price of the fish when they land.
Yes, exactly.
Yeah. Okay. Then it comes to the wind farms. You had a map showing where you were going to construct. I think this one. And where, as I can see, where they are going to construct them, there are very little fishing. The fishing effort.
Fishing effort?
Yeah,
oh, no.
Or isn't the red points?
Yeah, no, this just shows fishing location. It doesn't show the fishing effort, just like the pinpoints of VMS data. So it doesn't really show fishing effort.
Okay.
Just an illustration of how I use wind farm status of only construction and production, and then overlay it with fishing points.
Yeah, but the new ones, it seems like they're not going to fish so much in that area?
Oh, there is for the new wind farms. You mean?
Yeah.
No, there is no. You mean the construction?
Yeah, the constructions.
Oh yeah, no, there is no temporal basis here. I just overlaid everything.
Uh-huh.
Yeah, but this also is the fishing area for 2023. So you may not see that they are fishing around there, maybe because they have been also like exclusion rights at that certain time, per se.
I was thinking that they were actually thinking about this and put the wind farms where they didn't fish. Maybe.
Yeah.
Okay. And well, this is a huge job you've done, but it's only Belgium. I guess these fishing areas are used by so many countries.
Yes.
So what does it say when you just have one country?
Yes, I would actually like to further my research on other countries, but for this thesis, only focus on the for Belgium fishes context.
Yeah,
I
I understand the limitation, but
yeah.
still, did you see any other data like from other countries
no,
just for
not-
fun? Or?
Yeah, I mean, to even get this data, I had to sign a contract of no, I cannot share this data and all. So I'm not sure I'll be privy to see other data for other countries, just for Belgian fishes only.
Okay, thank you.
Thanks
Thank
very
you.
much. Nice presentation, well done. I have a few questions. So one that I was mainly wondering, you explained well why the C-square resolution might give better information than the IC squares. But I was wondering if you can expand a bit more on why you think it's giving you better results than the 1 kilometer.
Exactly. So I understand that yes, 1 kilometer will show a final precise output. But however, it will not leave room for spatial flexibility, whereby if there are changes within fishing, because not all fishing areas will become essential, even maybe from one year to another. It will be essential 2008, but it wouldn't be in 2012 per se. So zooming down to only one kilometer only, and let's say there's a shift, you wouldn't get to see the natural variability for 1 kilometer. But using C-squares, you get to see a larger expand. Okay, you get to see the shift from one area to another. That's why I say that.
Makes sense.
Yeah.
And in marine spatial planning, when people are like deciding NPAs and everything, what resolution are they using?
What resolution? That's the thing. It depends on the context you are trying to prove. For 1 kilometer, I would say okay, maybe for a scientific context, maybe you're only reviewing the Belgian Park de North Sea. Yeah. So that's a small precise area that you can visualize. But for MSP, I actually type want to use C-squares because as I
And
said.
is this being used like in, have you seen this as the main method in other literature? Or
Yeah,
how
exactly.
common?
Yes. I get to see when I was reading. I mean, one of the major literature, Jenny Zhang Li, and she used a lot of C-squares also.
Okay.
However, also the ice rectangles is also good. It's just like it shows, yes. I mean, way back, that's the historical data. So we can't just say, okay, let's omit this out.
Yes.
It also gives a really good overview.
Okay, good. And then I was wondering, like, how worried you might be about the overall effect of offshore wind farms, because from some of the numbers that you present are really striking and they sound really worrying, but then you have the disclaimer of this is a teeny tiny proportion. So if the results were presented in a certain context to planners, for example, you could have a major argument, and then actually if they dig into it, the disclaimer is, oh, this is like 2% or
Yeah, but that's the thing. It's difficult to judge if this is just a teeny tiny area. Although yes, the proportion of it within total within hour it's low, but again, it's hard to judge if maybe this may actually have an effect on major or may prove to be a major or small impact with this in isolation alone. So that I wouldn't know if maybe it's that huge of an impact per se. But I do know that yes, it's a small proportion. But then again, maybe coming down to the nitty-gritty situation may actually be a really take a large effect, maybe financial reason. And I mean, if maybe someone has a business and say, okay, 5% loss, I mean, it is small, but it's actually a really huge loss either way. But I can't really tell for sure.
Yeah, well, I think it's good that you have included the disclaimer and you mentioned it in your presentation as well. And not even a disclaimer, but like the proportion that you're talking about overall. I think that's important to present it in that context. So well done for that. And in one slide, I think it was about you were talking about the economic returns for the Irish and Celtic Sea, and you had a minus 75%. But when you were presenting, you said the economic returns remained. Yeah, like economic returns were maintained. I didn't follow something here because I see the minus 75.
Yeah,
And
yeah. Okay, yeah.
Can
This
you-
is just the order of decline per se. So I get order of decline for each area within North Sea and also Irish Celtic Sea. There was a difference within North Sea whereby it had the steepest, the least decline was in weight, whereby I tried to say that although even fishing activity were produce more catches, but in less profitable areas. That means when maybe if certain fishermen go to fishing within an area, but still they had catches within an area, but we just a little, but that area is less profitable, but it still gave a high amount of catches. But with Irish and Celtic Sea, they went to an area whereby even if it didn't and they couldn't produce so much catches within that place, but still they still have higher economic returns. That means maybe this area are highly profitable. I wouldn't want to say maybe they are catching high species because my data didn't have species data within it.
So what is that minus 75% then?
My first element 75% is just the decline of change between 2008 and between these two periods.
I think I'm still missing something.
Yeah.
So you're saying that there is a 75% decline,
Yes.
and then you're saying that the economic returns were maintained.
Yes, there was a 75% decline.
Yeah.
I understand, but it's just that the least decline within it was euros. It wasn't higher than fishing hours, which had higher decline. I understand that yes, maybe there was 75% decline. It's just that the least was still euros.
It was the smaller.
Yeah, it was
decline.
exactly.
Okay.
Exactly.
Okay.
But still there was loss, definitely.
Okay. Thank you. I think that's enough.
Do you have any questions?
Yes, actually my question is related with this slide. So, I was wondering that beyond these results, what do you think is the reason why this the catches decline within the wind farms?
Yeah.
I mean, it's just a matter of occupation of space, so the fleet cannot move.
Yes. Obviously, whenever wind farms want to be constructed or there's a lease for it, there's always exclusion rights. So we expect that there are declines within offshore wind farm if we're for fishing activity. That is why this was only done within offshore wind farms. But with MPAs, it was limited to just dispute analysis because not all MPAs have exclusion rights at the moment. And even some which do are only included within recent years. So definitely the reason why there were declines is because of exclusion rights, whereby if they are building an offshore wind farm here, definitely fishers are not meant to go there because it may rupture some pipes or some of the connectors to the offshore wind farm. So that's why there were decline within offshore wind farm area of fishing activity. But this wasn't the whole landscape. But because I wouldn't say that offshore wind farm areas decreased the fishing hours around the North Sea or Irish Celtic Sea. This was only within offshore wind farm areas.
And do I
Yeah, you have time. Yep.
So I think that you mentioned in the future perspective of your work that your results came from landings, if I correctly understood.
Yeah.
Okay, but the gear type was not considered.
Yes.
So in the future,
Exactly.
because landings of course depend on.
Yeah, exactly. Because for gear type, if that's included, some ships will experience major losses than other ships if we should include gear types and also vessel category. But yes, that is really a good one to note into this session. That's why it's one of my limitations.
All right, I will have a moment for a few questions myself. Well, Katie took away most of my questions, but I do like to go back to the resolution. I think you answered that in a proper way of saying, well, it basically depends on the what you're trying to quantify and its own scale. So that depends on that. So knowing that, if you were to let's say reanalyze the same regions by adding fleets from other countries or working in a different region, would you say, I'm going to use the C square because it worked well in this case, or would you be more partisan of always trying different scales and see if what works best in each case.
Exactly. Always trying different skills. I'll let the data speak for itself.
Mhm.
So I really want to try to omit anything at this moment because all this is still really valuable for MSP context per se.
Okay. And I guess all the vessels in the Belgian fleet are equipped with VMS. Do you have any data on the, I know it's anonymized when you get it, so I don't know it, on the behavior of fishers? Is it always on? Is it sometimes turned off? Do you have any idea about that?
I do not have any idea.
Because what you get is already anonymized. You don't even have an anonymous identifier for a ship. You only have the vessel, the fleet level.
Yeah.
Okay, so you have only the tracks. All right. Do you have any other questions for the jury members? Anybody in the audience have a question for you? You don't want to do that? Really? Okay. Gabriella?
Maybe I have one.
Okay, thank you.
So one tiny one was at the end. You mentioned in your final future perspectives. I think you talked about having spatially precise EFGs.
Yeah.
And then I'm just wondering, and I think maybe it's a bit like what you just responded to Olivier, but I think it's interesting to come back to the idea of your resolution and then how do you get spatially precise EFGs? Because of course, if you go for a coarser resolution, what's the precision? So I'm wondering if you can comment a bit on the precision needed for EFGs versus the different resolutions that you have.
Yeah. I mean, because mostly all these maps will have to be uploaded to the GeoFish platform, which is like an interactive platform for where managers come to, stakeholders, they come together and try to, play around or not play around, definitely work and see, okay, which best fits a certain situation. And I'll still say again, let the data speak for itself.
And for now, from your study, like for the EFGs, what do you think is spatially precise enough?
Yes, I think it's still this question.
Okay.
Because we could try to do some management on that specific.
That's good enough.
Yeah.
Yeah.
Software, yeah.
Okay. Yeah. That's it. Thank you.
All right. Thank you very much.
The chat was exploding.
Really? We're gonna wait just it's half past, so we just to make sure people online are here. So last but not least, Martina will present her work to close up this session. So you know the drill by now. Don't have to repeat. So whenever you are ready, the floor is yours.
Thank you. Good morning, everyone. Today I'd like to present the thesis research I carried out at Anton Dohrn Zoological Station in Naples under the supervision of Gabriele Procaccini and Jessica Pazzaglia, which focused on the molecular basis of its stress memory in the seagrass Cimodocia nodosa, and specifically on the interplay between DNA methylation and gene expression. So, seagrasses are maliprim plants that support biodiversity and provide essential ecosystem services in coastal environments. They consist of clonal modular units called ramets, which consist of a leaf-bearing shoot with its associated roots and interconnected by a rhizome, and they are produced through clonal reproduction. These foundation species are increasingly threatened by climate-driven stressors, namely marine heat waves, which threaten the resilience and long-term survival. To cope with recurring stress, they display stress memory mechanisms that allow them to remember a previous stress event in order to respond more effectively to future ones. Stress memory is also at the basis of priming applications, which involve experimental exposure to a mild or sublethal stress in order to enhance the plant's tolerance upon subsequent exposure to stress. In terrestrial plants, epigenetic modifications which are modifications that do not alter the DNA sequence itself, but rather affect its accessibility, such as DNA methylation, are thought to play a role in stress memory establishment by regulating gene expression. However, in seagrasses, due to the limited number of studies that simultaneously assess DNA methylation and gene expression under stress, it is still unclear whether the interplay between these two processes is at the basis of stress memory. This knowledge gap is particularly relevant in seagrasses, because being clonal species, clonal propagation could facilitate the persistence of epigenetic modifications across clones, raising the question of whether stress memory can also be transmitted across clones. The aim of my thesis was to address these knowledge gaps, and this was done by building on a previous experiment in the Mediterranean seagrass Cimodocha nodosa, which is a species characterized by fast clonal propagation, a feature that makes it a well-suited model for this type of studies. So, specifically, Cimodocha nodosa was sampled through scuba diving in a shallow coastal lagoon in Mar Menor in Spain. Plants were then transported to mesocon facilities where, after initial acclimation, they were exposed to a thermal priming, followed by a recovery phase that allowed horizontal clonal growth and a triggering stress, simulating a marine heat wave. So, primed plants experienced both the priming and the triggering stress. Not primed plants experienced the triggering only, whereas control plants were kept under ambient temperature throughout the experiment. At the end of the triggering stress, leaves were sampled and differentially methylated regions, or DMRs, were analyzed across treatments and across clonal generations, which are represented by shoots that were already present during the priming, defined as old shoots. Shoots that developed during the recovery stage, defined as new shoots, except the one at the actively growing tip, defined as apical shoot. The resulting DMR datasets were the starting point for my analysis. Specifically, candidate genes were selected from such datasets based on their reported involvement in stress memory pathways based on literature review, as well as based on specific methylation features. Particularly, candidate genes included components of the RDDM pathway, RNA-dependent DNA methylation pathway, a pathway which is reported in maintenance and establishment of stress memory in terrestrial plants, as well as genes associated with forgetter1, FGT1, another well-reported mediator of stress memory responses. DNA repair genes were also included, given their reported activation under priming in the seagrass Posidonia oceanica, and given the reported interaction between DNA repair and epigenetic regulation under stress conditions. Moreover, genes containing DMRs within the promoter regions were also included, because usually promoter methylation is usually more strongly reported to regulate gene expression. And finally, genes displaying opposite methylation patterns when comparing new and old shoots in primed and not primed conditions were selected to focus on methylation that likely reflects a priming-related effect rather than general development or stress response. Primers were designed for all the selected genes. Subsequently, RNA was extracted from 3 biological replicates of leaves per each condition. And after the proper quantity and quality checks, it was retrotranscribed, and the selected candidate genes were amplified through real-time qPCR to quantify their expression across conditions. Gene expression profiles were analyzed through Permanova, which revealed that clonal generation and treatment, together with their interaction, explained a large proportion of the overall variation in gene expression profiles. Moreover, pairwise comparisons identified the apical shoots as significantly different from both new and old shoots, whereas the latter did not differ from each other. This is consistent with patterns observed in the principal component analysis or the ordination plot, where we can see that all the new shoots cluster closely together, whereas the apical shoot is more separated, showing only partial overlap with the other shoot types. These findings suggest that the apical shoot may possess a distinct molecular identity linked to its unique role within the clonal fragment. In fact, this is consistent with the other findings in seagrass Posidonia oceanica, where the apical shoot has been described as a dominant module within the clone, whereas other shoots play more supportive roles within this integrated system that allows resource redistribution, specifically under stressful conditions. And this can result in distinct molecular signatures. Pairwise comparisons also identified no significant differences between primed and not primed shoots, whereas both of them differ from control shoots, suggesting that at this global level, transcriptional responses are primarily driven by stress exposure rather than priming effects, with evidence of priming not emerging at this level. However, when we move to the gene level, evidence of priming can emerge, and transcriptional responses are highly heterogeneous. Given the time constraints of the presentation, I'm not going to discuss the expression patterns of all the 17 analyzed genes, but I only chose a subset of representative ones. So some genes display no variation across expression, in expression across conditions, such as for getter1, where the expression in not primed and primed shoot is comparable to control conditions. Some other genes instead are stress responsive and appear to be differentially regulated under both not primed and primed conditions, such as heat shock protein 18.2, which is upregulated under both conditions when comparing not priming to the control and primed to the control. Finally, some other genes show priming effects which can be variably manifested across clonal generations, such as for ferritin 3. For these genes specifically, we can observe that in all the shoots there are not any significant changes in expression across treatments. However, when we look at new and apical shoots, we can observe an upregulation under priming condition, suggesting a delayed effect of the priming response. When we compare expression patterns to the corresponding methylation patterns of the same genes, no clear association between the two variables can be detected. In fact, even when we can observe differential methylation, this doesn't always turn into differential gene expression. And even when differences in gene expression are detected, they are sometimes mirrored by changes in methylation, but not across all conditions. So, like we can see for each of protein 18.2, but also for ferritin 3. So, to better describe the relationship between gene expression and DNA methylation, a Spearman correlation analysis was carried out, which revealed a weakly negative correlation between the two variables. Although this correlation is statistically significant, as you can see from this scatter plot, the data is very dispersed. And when the analysis is conducted at the level of individual genes, these relationships are not significant anymore. And also, they are not consistent, meaning that for some genes, we see positive associations between the two variables. For other genes, negative associations between the two variables. These results are in line with more recent studies that highlight that DNA methylation is not always a direct regulator of gene expression, but rather point towards a more complex and context-dependent relationship between the two processes, where DNA methylation appears to be only one layer of regulation, but it also interacts with other epigenetic modifications in shaping gene expression, and it's not always directly predictive of transcriptional outcomes. So, To recap, the main findings of these studies are that gene expression at the global level is primarily driven by clonal generation and stress exposure, with no evidence of priming at this level. However, at the gene level, responses are highly diverse, and the priming effects, when are detected, can be variably manifested across generations. Finally, DNA methylation shows a weak negative association with expression at the global level, which is, however, not robust at the level of individual genes. So, to answer the research question of these studies, thus whether the interplay between DNA methylation and gene expression is at the basis of stress memory in seagrasses, and whether such memory can be transmitted across clonal generations, the results suggest that stress memory in Cimodocha nodosa is regulated by a complex interplay of factors, with DNA methylation being only one regulatory layer, and with priming effects being variably manifested across the generations. In light of the findings of this study, it is important to acknowledge its limitations, which, however, turn towards future directions for research. So, within the scope of the study, it was possible to include only a limited number of genes, which makes it difficult to draw final conclusions regarding the involvement of entire pathways in stress memory processes. Thus, expanding the analysis to a broader set of genes would allow to clarify such dynamics, and particularly a transcriptome approach would allow not only the identification of genes relevant to stress memory, but also to compare transcriptomic and epigenomic data set at a genome-wide scale, allowing to better understand the relationship between gene expression and DNA methylation. Related to this study considered DNA methylation only. However, expanding the analysis to other epigenetic modifications, such as histonic modifications, would allow to better understand how all these processes interact and how together they could build stress memory. Finally, methylation and gene expression were analyzed only at one time point in the experiment, specifically at the end of the triggering phase. Time course analysis would allow to understand the temporal dynamics between methylation and expression, allowing to understand the timing with which these two processes are regulated. It is also possible that some conditions may respond at different timings. So, for example, prime plants may display earlier or faster response than not prime plants, but this effect cannot be captured within the current experimental design. So, for example, adding multiple sampling points throughout the triggering phase would allow to better clarify all this. I would like to conclude by thanking you all for listening and sending a special thank you to the Seagrass Molecular Ecology Group at Stazione Zoologica Anton Dorer. Thank you.
Very well done, Martina. Perfect use of your time and a very interesting and rich presentation. I think it's only appropriate that we start with Martina.
Congratulations for the presentation. I have one question related with the method, the setup of the experiment at the beginning.
Yes.
Yeah. I think the first slide. Okay, this one. So, if you can explain a little bit indeed how the mesocosm experiment was planned. I mean, how many replicates you put in the mesocosm?
Yes.
So if you can explain a little bit in detail.
So this part was done by my supervisor, but like the mesocosm were analyzed in this way. So like there were different tanks corresponding to the three different treatments. So there was a tank for the control plants, one for the not primed, and one for the primed. And within those tanks, there were like these fragments of the seagrass, which all contain a shoot that can grow. And so for each of them, like all the plants are in triplicates. So there were at least 3 fragments within each tank, and after the priming, like the a tag was attached so that the monitoring could be the growth could be tracked, and so that it was possible to understand which ones were the old shoots and which ones are the new shoots. And at the end of the triggering phase, it was sampled like old shoots from each condition, and new shoots for each condition for all the tanks. I don't know if it's...
No, it's clear. Much more clear. Thank you. And all the shoots grow at the end. Did you?
Yes, like all the plants should grow.
Okay. And I'm not really into the SIGGRAPH, but I am also surprised that in 55 days you already saw this growth.
Yes, it's that's the reason why it was chosen Cimodocia nodosa as a because Posidonia would be impossible because it takes ages to grow, but Cimodocia is a fast-growing species which is also described as a potential winner also under climate change, for example, because it can grow so quickly and colonize also bare sediment, for example. So, that's one of the reasons.
Okay. Thank you.
Thank you, Martina. Philip?
Yeah, thank you for a nice talk. This is not my expertise area, but I found it really interesting. So, when it comes to this priming and then you wait for the triggering, why these days and why not 50 days more or 10 days less, or why?
I think it was related to, let's say, give the plant enough time to grow. So, I think choosing a shorter time for recovery would not allow plant growth. And I think the start of the triggering was chosen also based on other studies in priming experiment and repository.
So the memory can be for a couple of months, but not longer. Or what do they know from land plants, for example?
This is still not well understood because it's very dependent, and so sometimes it seems like the memory can be maintained long, and some studies show even that memory can be passed down not only to clonal reproduction, but also to sexual reproduction. So it can even persist across sexual generations. I don't know if it's the most proper terminology. So, and sometimes instead, I found that epigenetic modifications may only last days. So I think it's very variable and dependent.
And then maybe it's difficult to actually choose the right.
Yeah, which I think it's also why it's difficult. And I was pointing the timing also as one of the main limitations because we don't understand still lots of things. So how long, and as you were saying, the DNA methylation persists, how long it takes then from once the methylation marks are established to turn into gene expression regulations. For some genes it seems maybe to respond earlier, sometimes later it's still all a bit different.
Now this is an experiment about genes, but since I'm an ecologist, I'm also interested. Can you see any effects on the, for example, the plant growth, things like that? Did they measure even ecological things?
So not, I didn't do it within my study, but my supervisor for her study, she measured respiration and photosynthesis rates, also to establish if the priming treatment had actually worked, because if we don't see a positive response of the plant, then it means it's not actually being primed. So she measured that, and she observed that after the triggering stress, the prime plants showed similar photosynthesis and similar respiration to control plants, and meaning that priming has been beneficial for those plants, whereas such response was not observed in the not prime plants, which show lower photosynthesis and higher respiration. And but
Thank you.
Also, as an ecologist, I feel doubly challenged now because that was one of my questions. But yeah, really nice study, well done. So I think maybe picking up again on this, because as I was saying, I wanted to ask a bit about the plants themselves. So, but even you mentioned that they measured photosynthesis and something else. For evidence of priming.
yes.
But do they look at the phenotype? Like, how is this gene expression for heat stress related to the phenotype or of the plant, or have others?
Not really. I haven't done that.
Or did you come across it? I know not in this study, but did you come across how they're related in the literature? Like, have people done these priming studies and seen that it can improve the phenotype? Or?
Okay, so like improving in phenotypes, yes, absolutely. And like most of the priming studies focus actually on phenotypic studies, and the point is that there's more a lag related to molecular mechanisms, but absolutely, like on term of phenotype, like also other parameters have been measured, and also priming is being applied also to restoration trials, and prime plants seem also to perform better compared to not prime plants. So
yeah, and then is there any, like, I know you said the molecular work is limited at the moment in the area, but have there been any links made between the gene expression and some phenotypic characteristics, or are we not there?
I wouldn't say that, but I think like some of the changes like would be in line with that. So, for example, like as I was showing earlier, I see an upregulation of ferrimectin-3, for example, and this molecule is a molecule that binds free iron, which is an oxidant agent, and I've seen in many different studies that this molecule has been upregulated under stressful conditions, and so like this, let's say, allows the plant to suffer less the damage on top of other damage that might be ongoing due to the stress. So I think like this kind of supports this idea. So if you observe that a plant is doing better and we see some genes that are more expressed, for example, that could be.
Yeah, to make the links, that's cool. Trying to tie the two together. And then I think it's the next slide. Is the next slide this study one? Yeah, here I was curious. So in this study, does that mean that you started off by going to these databases yourself and doing the primer design yourself?
Yes.
Okay.
Yes.
And what background did you have going into it?
During my bachelor, I studied biotechnology. Yes, and so I did like something not in sequences, but something similar also for my
because
bachelor.
otherwise I was thinking in like a 6-month project. This is
no
extremely challenging.
No, I had a bit of
okay, great, good.
Yes.
So and that allowed you to do a really substantial study on the topic.
Yes.
Yeah, I think that's it for me. Well done.
Thanks, Katie. Yes, I also wanted to come back to that slide and ask what exactly what was your role in all of this, because it seemed like a huge amount of work, especially if you had never done it before. So that's really, we can all commend you on that. You unfortunately have no members of your jury that are specialists in your field, which is unfortunate, so we're not able to ask the difficult questions. But maybe I can ask you some questions on the sampling, on the experimental design and the analysis, so that these might be more in my field of expertise. I was wondering, if I understand properly, you had 3 tanks, and in the 3 tanks you had 3 shoots, right?
Yes.
1 tank per treatment. Do you think that's ideal?
I think like in this way, like
I can phrase it the other way. Do you think there might, because you're using your shoots, your 3 clones in each tank as replicates, right?
yes.
But do you think the effect might be linked to the tank rather than the individual?
That makes
That
sense.
could happen. We understand the logistics, okay, of the difficulty of, ideally, like you would do 90 tanks. Each connected to its own water supply and water temperature control and salinity control, but we understand. But you might have a tank effect and not an individual effect. So that's something to think about, to at least be aware of. You'll finish soon, don't worry. I'm also wondering, did you take into account, and I get the feeling you did not take into account I don't think your data is completely independent. And what I mean by that, when you I don't think your data is completely independent, regardless of the tank. Okay, forget the potential pseudo replication. You're as you said clearly, we got that. You go at the end and you sample the old, the new, and the apical elements, and then you compare the values in each. And we see clearly in your univariate analysis that you have these values that you compare, okay, between treatments and levels, but you're not using the fact that some values come from the same clone. Is that put like the fact that these values are paired, because you have values for in one condition from the old, the new, and the apical, but I don't think that you put anywhere in your analysis that they're from the same clone. You see what I mean?
Yes, but actually, like that is not necessarily true, because it's like it doesn't necessarily come from the same fragment, so it might be the new. Like I'm not 100% sure of the designs of the tanks, because as I was saying, I did not do that experiment, but it might be that there were even more than 3 fragments,
Okay,
like
so you're
maybe
not
5,
sure of that.
and that it might be like I have triplicates, but like the old shoot might be from plant 1, 2, and 3, and then the new shoot might be from plant
6,
3,
7, and
4.
8, and whatever. Okay,
Yes. So it's not necessary.
You had nothing to do with that, but it's a bit unfortunate because you would have more statistics, even with small sample size, if you had that information and you include it in the Permanova, in the univariate, you would have more statistical power, even with small sample size. So that maybe for future experiment, it's something that to take into account, because you're still seeing things, and you could maybe see a little bit more if you include that. And it's something that's often forgotten in such experiments. I see it often that people don't put it, and it's really unfortunate because you have more power than you think.
Yeah. No, that's a good point.
Congratulations, thank you very much.